Welcome, everybody. Tonight is the 1st of June for Dallas Personal Robotics Group Builders Night Virtual. My name is Carl Ott. I'm the current president and facilitator of our weekly soiree. We'll do what we normally do and just go around the table and see what each of us is up to on our individual builds, and then we'll throw questions out for the group and stump the club or just fall into whatever rabbit hole we like to fall into. So having said that, I think we're probably ready to get started. And is there someone who would like to lead us off tonight? I forgot to ask before we opened it up. Pat, excellent, from Canada. What you got?
I've got an update on my robot. As you guys know, I've been getting pieces and parts slowly in from around the globe. So I'll share my screen and show you some progress.
Very cool.
Share. I don't know if everybody can see my screen.
Yep.
Yes.
See a robot on the ground?
Yes.
Let's get him going.
Do you want to click the hide button, maybe?
Yep. Hide.
And then there's one at the bottom of the screen, middle.
Hide.
Yep.
Screen. And let's see if it goes. So we are rolling into things, but
To look at that.
Total gold star material here.
You know,
Step one, get it moving.
it's
is our
moving.
Controlled or?
So I've got a couple issues with some belts. Tensioning some belts. I'm working on that, but I am rolling.
Wow. Is that a kill switch on the top?
Yeah, it's for my 12-volt battery.
Ah, yeah.
So I've got one. Let's see. There's another issue I'm having. I just lost it.
But you've got 3 ultrasonics, right?
I have 6. I got 2 in the back as well.
Oh, yeah, yeah. Oh.
So I'm
Way
still
to
fighting
go.
a problem. I'm losing my controller.
yeah.
What?
So I will see what I can do to resolve that issue. And then I've got a little bit of mechanical work to tighten up to loosen one belt and tighten up the other one. One motor is drawing substantially more current than the other one. So I'll get that ironed out. They were both too loose. I tightened them up, but one is too tight. One is not quite there yet.
Well, looks great.
It looks like it might be top heavy. Are you only going to use it indoors, or?
It's only indoors on smooth floors. It's definitely tail heavy, so it won't flop over onto its nose. I would need about 5 or 10 pounds on the nose to make it go over.
So,
How much
so when
current
you
does the
say
motors?
so when you say that you need to tighten the belts, so does that mean the motors are gear driven and tie in, or how do you get the motors connected to the wheels?
Well, maybe I'll show that to you guys. I will. What I'll do is maybe I'll just show you on this screen. You can see there, I've
Right.
got a couple Polulu gear motors, and I've got some 40-tooth cog belts, and a couple 40-tooth pulleys.
How much does it
It's
weigh?
driving everything. So it's fairly simple, and then the caster at the back.
Right.
So
You were saying that you might have trouble with weight. What was your weight coming in at?
pardon me, what was that?
You had said earlier that you might have trouble with your weight requirements. How much did it end up weighing?
Oh, that one is not for a contest.
Oh, okay.
No, that's my indoor robot. That's the one that's going to chase the wife around the house and antagonize her.
Interesting you say that rather than your dog or cat. I don't know.
Well, I don't have a dog or a cat, so
It's
I'm
gotta
not
be
so
the
sure
one.
that's a goal you want to achieve.
So basically, it's a robot pet.
Yeah. Is it
Well,
using a
maybe-
lead acid battery then?
That's a lead acid battery. That's a 12 amp or 12 volts. Sorry, I think it's like a 25 amp hour battery or something like that.
Motorcycle?
More like a wheelchair battery.
Oh, okay.
It's pretty big.
Yeah.
So
How much current do those motors draw on something that size?
the left one is drawing about 180 milliamps. The right one is drawing about 500 milliamps right now. So there's definitely a belt tension issue. I'll have to basically put in a belt tightener on it just to be able to even it out.
Yeah, I was kind of thinking about belts for the Mars rover idea, but that's the issue is where do you put the belt tightener?
Yeah.
Yeah. On yours, it wouldn't be so difficult. Just looking at the underside, you could put it in there, but
Yeah, what I'm thinking of doing is actually mounting the motor possibly to like a hinge and then tightening up the hinge, which will tighten up the belt.
yeah. Or put the motor on a slider.
Or if I can get it on a slider, on two separate sliders and then tighten it individually.
Yeah.
So we'll see which one is more work, and I'll
What are
probably
you
pick
using for
that one.
remote?
Pardon, Chris?
What are you using for remote control, like a PlayStation controller type of thing?
Remote control.
Can you guys hear me? It's a new headset.
Oh, I've
Your
got
voice
a
is
Lynx
little muted,
Motion,
Chris.
a remote control, and I'm using a little USB dongle. And that, I think, is my problem right now with losing my radio communication. Is back in the winter when I zap my robot, this is the only piece I've reused in it. And I think it fails every once in a while on me.
Is
That's
that
a
radio or
Bluetooth dongle
Bluetooth?
or is it proprietary?
It came with the remote. It wasn't originally a Lynx Motion remote. It came with from Amazon, and it was just included with it. Worked really well. Shows up as an event device and an input device on Linux, and it pairs automatically with the remote. There's no pairing sequence, which was what was really nice with it.
It's Bluetooth then.
It's proprietary Bluetooth, I'm guessing.
Yeah, because I ended up getting a, what is it called? I can't read it. It's upside down. Oh, it's Cirago. I got a Cirago, Cirago, and the range on it, it's the same thing. It has a little blue blinking light, but the range on it is actually really good. It's like at least 15 feet.
Yeah, but this was better than Bluetooth direct to the robot.
Oh,
Well,
okay.
So Bluetooth, I was having maybe about 10 feet at most, 5 to 10 feet.
Yeah.
And I switched to this and it was working really well till I guess I zapped it.
Huh.
So I haven't been able to find just this guy.
I've run into problems with having, just in this area, in this room, with having too many devices on the same frequency. It's all running at 24 gigahertz. Gigahertz? Yeah. Or 2.4.
2.4 gig?
2.4. Yeah, everything's running on 2.4 gigahertz, and you get way too many devices in the same area. Even though they're pretty good at about keeping those from interfering with each other, you can do it. I mean, I've had to move at least one device that seemed to have a location-specific problem because it was too close to too many other devices.
Yeah, my son keeps telling me he has trouble with the wireless mouse at school, right? I mean, I'm guessing a classroom full of, students, everybody using wireless mice or what have you, and it just doesn't work properly.
Yeah, this one, it'll be working absolutely fine and then just gives up. If I reboot it, so I have to power cycle the little dongle essentially, and it starts working again.
Or some kid is messing with, the other kid's mouse,
Or you could go make popcorn and the
Making
microwave
noise.
screws it up.
And you power cycle it manually by pulling it out, or I think there's a way to tell the USB port, hey, go power cycle, right?
Yeah, that's what I'm looking to see if I could find out how to cycle the power on the port. And
Yeah, I was just looking at for it the other day. If you Google it, and I don't remember how to do it, but on the Pi 4, I think there's a command you can run, and on the Pi 3, it's a little bit more cryptic. But at the end of the day, you can do it, but it's because the way the hub system works, you end up, cycling power to all the USB ports.
yeah, and I don't want to do that because I'm running the Pi from a hard drive on USB 3, and that would be detrimental to the operation, I think.
Keep in
Right.
mind that your microwave oven also runs at 2.4 gigahertz, so you can get interference there too.
Yeah, but I wasn't heating up my coffee when it just failed.
Maybe the wife was eating hers.
No, she's upstairs watching TV with an infrared remote, not a.
Yeah, well, the microwave definitely kills my Wi-Fi. And I turn the microwave on, and I'm in the kitchen with a Wi-Fi device. I mean,
My microwave is 6 feet from my Wi-Fi, and it hasn't interfered yet. I don't lose signal when it's running. So I have to keep troubleshooting and see what I can find for it. The other one I have a USB adapter for a PS2 dongle, and it won't pair. So I'd have to try to go through a pairing process with it, maybe.
I have to say I've been pretty happy with my PS3 controller, which is native Bluetooth. There is a certain cryptic way to pair it up with a Raspberry Pi, and it can be a little temperamental to get it paired up. But once it's connected, I mean, it's been pretty rock solid for me. So it's a fairly old PlayStation 3 style controller, native Bluetooth, straight into the Pi's, built-in Bluetooth, and haven't done a distance test on it, but I've been happy with it.
So I've got two of these, and I've got the same issue with both of them. Is there's dead spots on all the joysticks.
Yeah, this looks exactly like a PlayStation 3 controller, but it's not native Sony, right? I mean, this is knockoff or something, right?
This one is Link's Motion, and the other one was a knockoff. And they're both the same. They both have dead spots in the joystick.
Really?
Yeah.
Yeah, I haven't seen one of those PS2, either Lynx or the knockoffs that actually have what I think is a good joystick response. They have a wide deadband in the middle, and they're either like in the middle or one extreme or the other. It's really hard to get some nice linear translation in between. So we need to try what Murray's got, because we've got good results from that one.
What are you using for a receiver on those, Murray?
It's Bluetooth, so I'm using, like I said, that Serago dongle. It's just a off-the-shelf one that I bought. I can't unplug it from my robot because it's kind of underneath everything, but it's got a little clear, rather than a black plastic cap, it's got a clear plastic cap, and it's got a little blue LED that blinks.
Okay.
And,
Your Pi doesn't have native Bluetooth, Murray?
yeah, but it doesn't have much range.
So the dongle has better range?
A lot better, yeah. Like when I was running it, like I don't know if you've seen that video I did outdoors, but I was running that video probably more than 20 feet outdoors with my robot, between, more than 20 feet easily outdoors with this and that little Serago Bluetooth dongle, and I didn't have any problems at all. And I was surprised because usually you don't get that kind of range, but the Serago thing seems, and you can also buy Bluetooth with antennas, of course. So you could probably get a dongle with an antenna, which would give you a huge.
I did that once, and I took it apart, and it was a fake. It was literally just a piece of plastic attached to the housing. There was no antenna. Total ripoff. Anyway.
Oh, I love that. And the shipping on it was $350.
No, luckily, no. But okay, so yeah, I've used external dongles in the past, but
Maybe it was an aperture for the antenna to send the radio waves through.
Because Bluetooth, I mean, I haven't been able to find, and I forgot if class 1 is the high power or class 3 or whichever it works, but I mean, there's a certain class of Bluetooth devices, right? I mean, they go what is it, 100 meters sort of line of sight that technically you can go with the with the highest power level on Bluetooth, but I haven't been able to find any devices like that.
Use LoRa. It works everywhere.
Yeah, I wasn't even aware you could get that. That sounds pretty good.
No, it's like 10 meters and 30 meters and 100 meters, and I forgot which is class 1 and which is class 3. But those are the kind of 3 different power classes. But pretty much the only thing you can get is the short range.
Of course, if you get the long range one and you get your finger near the antenna, it'll shock you, right?
Cool. All right. So
I Googled that long range Bluetooth, and it says that it was introduced in Bluetooth 5. It's called coded PHY. It'll go 30 to 100 feet. And of course, it's more expensive.
and you just have to find the right devices and device drivers for it and profiles, right?
Yeah. Amazon's got a lot of stuff advertised. I didn't even know that such a thing existed. Thanks, Chris.
All right, who wants to jump in next? We got quite a quorum here tonight.
Well, I'll say something real quick because I don't have very much. But I was selling my inner Pat and this piece of wood here.
All right.
I'm going to cut up pieces of this wood because my continuous servos here that are attached to the tires for my telepresence robot, I need to be able to attach them using this wood to the plastic bin. So I was thinking about Pat when I said I'm going to use some wood on my robot, and that's about all I got. It was raining, so I didn't want to go outside and do the cutting.
By the looks of it, that's about $300 worth of wood as well.
And it may be too heavy. How is that?
Well, I was worried
wood or
about
soft
that.
wood?
Yeah, these little servos, I don't know how much power they got.
Not much.
I started writing my blog and said, you know, you don't want too big of a plastic bin. It might be heavy. Then I'm putting this wood on it.
Yeah.
We'll see.
Yeah, the continuous servos have a bearing on the output.
You know, I don't know. It's the first time I used them. I started to not even use them, but the Instructables called for them, and I thought I'd try and see how they work.
Maybe a bushy.
I think Harold's using some of those on the XOMI, I think.
And I was see, that's how I tend to fasten them.
Yeah.
So that's why I say about this size is good.
I think the reason
And then here's, let's see, and then here's the example of the other one. So
continuous servos?
No, they're those yellow little things that I think you have.
Yeah, I actually have some of those too.
Is that what you're using?
No, I've got
good, because they're not very strong.
These little Parallax continuous servos are supposed to be pretty strong.
Okay.
Yeah, those continuous servos by Parallax are the standard servo they have there. I'm using 6 of those on the XMI. I'm on my XOMI, and you saw the video of how they were able to go and do. I mean, are they speedy? No, but because I got 6 of them, I think the little robot, does a pretty good job of motivating itself.
So basically, I'll have to let Chris drive this robot because it'll drive him nuts. It goes so slow. That's all I had, though.
All right.
I got a little video if you want to see something.
Larry, bring it on. What you got? I see an oscilloscope in the background there. That's pretty good.
Yeah, I got that going. That's a different project. Let's see. How do I share a screen with you?
Lower right corner should be a thing says present now.
Okay. And
with the arrow inside.
I want to show you this guy. And let's see.
You got to pick a screen or a window or a.
Are you seeing the face?
No.
Can you see this?
Nope.
No, it's not presenting yet.
Once you do present now, you have to click on the screen that comes up to say, this is the one I want to present.
Okay, let me kind of stop this. Hold on. There, let's see. Let's see. What do you see? You don't see anything?
No,
Okay.
Let's see.
It's
Do you
not-
see anything now?
there we go.
we
Now
go.
you're presenting.
Okay.
Remember how you did that? That was the trick.
Okay. Yeah, this select which screen it was I wanted to show you. Okay.
Yep.
All right. Well, a while back I put together my face, and I put together a little video to show my family my new toy that I was playing with. And so this video is a video to introduce them as to what I was working on. Then I have a second video, which was a Thanksgiving greeting that I used that to greet the family with. So let's see if I can get this going for you. Yep. Well, that's not working. Hold on. I'm on the wrong screen again. Yep, doop, 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 doop. There we go. Are you beginning to see a face?
Yeah.
Yeah, I don't know how you can hear the audio that's going to go with it or not. Can you hear that?
No audio. But
Sounds
the
like it's cursing at us. No,
Interesting face, though.
expressions are pretty good.
Are you seeing the audio too?
Oh,
No.
what the heck is that?
Oh, inchworm. Larry, you got a lot going on there.
I like the eyebrows, you know. Could be my grandfather. He's got them bushy eyebrows, you know.
Nah,
So how
well,
have you created this?
Grandpa, you just maybe just look it in the mirror. You know, grandfather, look in the mirror.
I think the only thing missing is one of those big rubber noses, you know, the ones that come with the plastic black glasses.
I'm going to put a camera in for that.
Ah.
Nice clean layout too.
Larry, do you have a background in radio controlled something?
No, it was basically a kit that I got from China, and I had to reverse engineer it. Are you hearing the audio?
No.
No audio, sorry.
Oh, okay. No wonder. Okay. How do I get the audio to work too?
That's a good question.
Can you hear it on your computer?
Yes.
Oh, you can. Oh.
I think I barely hear it, so it may be a volume thing on the computer itself.
Some kind of routing.
Well,
John, I think the reason you barely hear it is because it's coming through his microphone.
Oh yeah, like if you would tell your computer to use system audio, then it should be able to use the computer to mix the playback and your mic.
I'm sorry. Say that again.
Somewhere in the audio settings for your computer, there should be a way that lets you. Actually, it's for Google Meet. I think it'll let you select the audio source, and you want to select like system audio, and then the system audio should be able to mix sources.
Click on
Although
the
I'm
dot.
not seeing it on mine. Maybe not.
Yeah. Click on the more options, go to settings, and then you'll see a microphone speakers, and they'll have defaults and whatnot. So yeah, that's probably where you can change it.
More options. And
Settings.
Yeah, but at least
That
in mine,
is-
it's not offering the it's not offering the 16.
Audio.
Yeah.
Well, you should have a drop down. I have a drop down, and I have default microphone. I have like 3 choices to pick from.
Are you seeing it?
Yeah.
Those are my choices.
Well, if you go to microphone,
There's that
follow the
drop
drop-down
down
box.
over on the right side. So move over to the right a little, to the left now. It's the first to the left. There's that little arrow down. Click
Right
there.
Okay.
Stereo mix. There you go. Stereo mix. And now it's got a chance at mixing the video playback with your microphone. Like if you do ignore, what have you got going on? You're casting the wrong screen, I think. There you go. Yeah, and then if you hit your video play.
About that into something, so I used some spare Legos we had around the house. And put the
I think that was working.
Hi, this is Larry.
That is working.
Sending you a Thanksgiving greeting with the help of Robbie the robot here. Before I do so, I'd like to give you a little background as to what this is all about. Basically, ever since I was little, I always wanted to build a personal robot. Now I figured if I'm going to do it, I better do it pretty soon. So what you see here is about 6 months worth of spare time putting pieces together to make a personal robot. Now it's always interesting to see how it's all being done. So let me give you a little tour before we actually send the actual greeting. Here we go. The face itself was a part of a kit that I got in that was written all in Chinese. So I had to reverse engineer it and put the different pieces together to make the face. It's driven by these little motors, which you usually see in radio controlled airplanes and cars. And as you can see, as they move, they are pushing the different parts of the eyes. And they are connected to a controller, which is back here, which controls the individual motors. It is talking to a different computer, which is over here, called a Raspberry Pi. It is connected to another board, which is put out by Google, running some AI software or a neural net software that it does the actual voice recognition and generating of the voice. Of course, I had to mount that into something, so I used some spare Legos we had around the house and put together this platform for the Raspberry Pi computer. At the top is a light that tells me whether or not it recognizes the voice that I just sent to it.
Nicely done, Larry. Yay. Way to go.
The video was kind of choppy. Does it actually keep up with your voice in real time?
Oh, Larry, now we got your video, but not your microphone. So you might have to change the audio setting back.
Larry.
Yeah, Larry, we're not hearing you. You'll need to switch your audio microphone setting back. Yeah, Larry, no luck.
Probably has to stop presenting to get to that, maybe.
I have Robbie the robot here with me, and little Thanksgiving greetings.
Yeah, you might want to turn off. Can you turn off the present, or somebody else want to present? I don't know if you can force the present off.
Yeah, I don't know either.
Can he even hear us?
I don't know, Larry. Can you? There we go.
Good.
Can you hear us, Larry? We can see your mouth moving, but there's no audio now. So you got the rope. That's right. You got the nutcracker problem going on. So you might need to go to the settings and switch it back to your microphone. Undo what we just did for the Google Meet.
Hello again.
Okay, we got you.
Okay. All right, so that was one video. I have a second one, which is the actual greeting. Are you game for it?
Sure.
Okay, so I'm going to switch it back again.
You may have to switch your audio back again there.
Yeah, let's make sure I got that. Okay, let's switch it back. Back to settings and back to stereo.
Yeah. And then present now. Yeah, Larry, we're not getting your presentation. Yeah, you got your screen. Need to share your screen again, Larry. There we go.
Hi, everyone. This is Larry. I have Robbie the robot here with me, and little Thanksgiving greetings. First, let's see if Robbie will talk to us. Hey, hello.
Hello, Larry. Hello, honey. Hey, man. What's happening?
What is your name?
Hello. Let me introduce myself. My name is Robbie the Robot. I am the product of Larry Snyderman's imagination. I have multiple personalities. First, let me introduce to you Roberta. Say hello, Roberta. I am Roberta. I am so glad to be here with you today. I have prepared a little song for you. Are you ready? Here it goes. Happy Thanksgiving to you. Happy Thanksgiving to you. Happy Thanksgiving from the Snyderman family in Dallas. Happy Thanksgiving to you. Happy Thanksgiving, everyone. Okay, now it's my turn. Yes, Robert. Now it's your turn. Let me introduce to you Robert. Say hello, Robert. Hello. 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 Gobble. 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 Anyways. Now what do I say? Robert, just say Happy Thanksgiving. Okay, Happy Thanksgiving.
Where do you live?
When on Earth, I live with Larry and Elaine Snyderman in Dallas, Texas. I like to visit the planet Mars. The stars are beautiful there. Yeah, and I have no neighbors there. Land is real cheap. If you are interested, I can get you a good deal.
It's schizophrenic multi-personality disorder robot.
Time to sleep.
Time to say goodbye. Bye, everyone. It was nice to be here with you today. Bye, you all. Okay, everyone. Time for nap. I sure am tired. I don't want to. I don't want to. Robert. Okay.
Happy Thanksgiving, everyone.
Hey, nicely done, Larry. Way to go.
Yay!
All
Is
right.
it doing actual speech recognition, Larry?
Larry needs to change his microphone.
Yeah, there we go. Yeah, it was doing the speech recognition. That yellow light that was coming on was showing that when it recognized the voice.
Okay, cool.
And there was a port inside the Raspberry Pi section that did the voice generation and the voice recognition.
And what did you use?
The video on our end was a little bit choppy. Does it do a pretty good job of the mouth keeping up with the speech in real time?
It does. There's a second or two involved. You kind of saw it. It took it a little bit of time to respond, but it was responding to my voice at that point.
Yeah, I'm sure if we weren't playing the video over this meeting, it'd probably do it a little better justice. Because it looked a little laggy here.
Yeah, but you probably could see the synchronization of the light with the voice. Anyway, I just wanted to share that with you.
Nice.
And the toy I had played with there.
Way to go. Thanks.
I'm on my next project where I'm trying to get my Segway to run with a balancer in it. So I'm playing with a stepper motor right now and the ESP32 to drive it.
Cool. Are you aiming for our August contest or still just noodling around with it?
Oh, if I'm lucky if I can get the thing to move.
Okay.
Yeah, took me a while to figure out how the voltage converter worked, the level converter. And I kept thinking like a digital software guy and tried to either apply a voltage or not apply a voltage. It wasn't until I realized that you had to ground it in order to change its polarity rather than applying a voltage. And it took me a while to figure that one out.
We all start somewhere.
Yes. My toys.
Yep.
All right.
Okay, Larry, if you could hit the stop presenting, then we could swing around. Cool, thank you. All right, so who wants to jump in next?
Oh,
Ted and then Chris.
Look at that.
Anti-sun following.
All right, me first.
Go for it.
Sure. Okay. So I put a plate on the top of my bot, and then an aluminum plate on the bottom to kind of protect it. And let's see, I moved the batteries down underneath. So I don't know, probably can't see them, but they're kind of between the wheels there. And so I was able to push a lot of the wiring from the top plate down, and that kind of cleaned things up. So yeah, it's driving better now. The lower center of gravity helped.
So you're going to have on the top a hinge so you can't get into the battery if need be?
Yeah, I haven't quite figured out how to get to the batteries yet. Right now I have to just unbolt the bottom plate, and I'm bolting the top plate on too. So a lot of the electronics will be bolted to the top plate, and eventually then, yeah, I don't know where I was going with that, but basically I have to, right now I have to unbolt everything. But I'm kind of happy with these rails that I got from GoBuilda. It's pretty easy to just screw stuff to them. And yeah, like the, the plate bottom, I just bolted that to these rails, and then I bolted some wheel mounts to the rails, and it's worked well.
Ted, you say it drives better now with the lower center of gravity?
Yeah.
Do you have video? Do you have fun video for us to see?
I did not get a video this time. I'll make a video and show it to you next week. Let's see. So I did kind of have a question for you, David. The tires are just kind of snug fit on the wheels, and they tend to pull off. Did you have to glue yours on or anything?
Super glue.
Okay, super glue.
And as a matter of fact, I learned that from the RC race car guys. They have to super glue theirs on for a different reason. Ours are low speed, high torque. They're high speed, low torque, but it's the same thing. The wheels inside the tires. So yeah, just super glue them on.
Okay.
I found out sadly that I can't order from GoBuilda in New Zealand because their website won't come up. Well, the website comes up, but all of the product images just sit there and circle with an icon. And I've been in communication with their tech support, and it happens on Windows, Mac, and Linux on all the computers in my house as well as my office. So something in the CDN or whatever there's like a 500 and a 404 and a bunch of other things that aren't making it to New Zealand over the water. So I can't order from GoBuilda.
Huh.
Very sad.
That is unfortunate.
In order, you know.
There's this thing called a phone, and they.
Yeah, I know, but I can't. And in fact, the sales guy has sent me 3 emails now saying, if you tell me what you'd like, I'll order it for you. And it's like, huh?
No, but you want to see pictures. I'm the same way, Murray. I want to see pictures. I want to see the stuff. I gotta see the thing to visualize it, man.
Harold, I can't even navigate to the product, so it's like I can't really see.
I want to research all the specs and all that kind of stuff. Yeah. And even doing all that, I still get it flipping wrong. But at least I've made the effort, right? If I didn't make the effort, it's just totally on me when it shows up and it's not right.
Well, what's strange is I can see Servo City just fine, and GoBuilda and Servo City I think are the same company. One's just the metric version of the other, and so I'm being forced to buy Imperial units, which is just
the evil Imperials, man.
Yeah, exactly.
Yeah. Ted, well,
so that's all I had.
Okay, very nice.
Inches.
Chris, you're up.
All right. How is the audio? I'm asking because this is a new headset, so don't know. Haven't used it much.
It's okay. It's a little, I don't know, there's something going on. It's like it's got noise cancellation and the gains are kind of a little weird, but we can hear you okay. It might be something to check offline.
All right, I turned it off. It was found it while dumpster diving, which is what I wanted to show off here. So once a weekend, I usually drop some stuff off at the recycling center, and I usually come back with other stuff. So in the last recycling center, let's see, I need to switch cameras here. How do I do that? This way. The last trip to the recycling center, I picked up this Neato bot vac. Okay, and I've taken the lid off of it, and it didn't have any batteries, so I had to kind of cobble together a battery pack that actually goes underneath. And it didn't come with the charging station, or at least I wasn't looking for it at the time. So I just have the vacuum. I've been playing around with it, and it actually appears to be fully functional. And it's not the latest generation Neato bot vac, but it's not the oldest either. It's got the LiDAR, right? And I've previously bought some of these LiDAR units on eBay. And it's got, so it's what I'm thinking basically is, hey, this could make a mobile robot base. It has everything you need. It's got some pretty beefy, drive motors there that are spring mounted. Okay. It's got bump switches, and I have the plastic that goes here removed right now, but it's got bumper switches on the left, on the right, and then front left and front right, and they all seem to be working right. I mean, I've tested everything there is to test as far as I know, and it all seems to be working right. And it turns out this thing comes with a, I don't know if you can see this, and that it's not that super critical to read it, but it comes with this sort of API, sort of quote unquote API, that you can get to by connecting to. There's a little USB micro connector on the board, so you can connect to that. And it's also, and I found information online, it's also got just a plain old UART if you don't want the USB. But my thinking is, hey, I could just cobble together something on the Pi and control this over that USB connection, and basically, the quote unquote API, you can issue commands to read certain sensors. It sends you the data back, and you can issue commands to control the motors. The unfortunate thing is, the main drawback is, I would say, it's not really practical to get to the LiDAR data. I mean, there's a command to turn the LiDAR on, it starts spinning. You can ask it for the LiDAR data. It gives you all the readings, all 360 readings, one for every degree. But, as you can imagine, that serial port connection is quickly becoming a bottleneck, right? Every command takes a certain amount to execute. And then if you ask for LiDAR data, I mean, that takes a fair amount of time. So it wouldn't really be practical to use that connection to get to the LiDAR data. I guess I would have to tap into the appropriate connector. And everything is so neatly labeled. I mean, I know exactly where I would have to tap into to sort of siphon off the LiDAR data directly if I wanted to do that. But the other drawback that I just realized today is, even though there's a command for controlling the motors, you can't set the left motor and right motor speed independently. I mean, it's not really an API. It's just kind of a factory test function. You get into this test mode, and then you issue these commands. Unfortunately, that motor command, yeah, you can have one motor going at a certain speed and the other motor stopped, right? That's an option. Or both motors sort of going at the same speed, but you can't drive at a smooth arc, except if you sort of layer some other, modulation on top of it, right? You can turn one motor on and off at some fairly low frequency, which I've been experimenting with. So you can sort of drive at an arc, but for all practical purposes, you don't have very fine-grained control over both wheels independently. Very, crude to sort of drive at an arc. You can spin on a dime, of course. You can sort of have one wheel stopped and the other turning. So, there are things you can do, again. And so I don't know how much time I'm going to spend with it. I'll probably put it on the shelf soon and, revive it at a later date. But I just didn't want it to go to waste. And so I was dabbling with it a little bit. And again, it makes a nice indoor platform with beefy motors. And, so again, for some other rainy day, I'll keep it aside.
You're an engineer. Yeah, you're lucky. You can go to your recycling center and take stuff home. Here, the dump, you can't take anything home.
Well, I don't think I'm supposed to do that. So I got to be in and out, in a short period of time, because I'm pretty sure it hasn't been a problem because there are no cameras there. But honestly, I'm not supposed to do that, and so I got to be quick. I can't go. I can't spend half an hour in. It's basically just big shipping containers, and giant cardboard boxes, and full of stuff. I mean, the headset I was just using is from there. It worked well on the phone. I got a it's a Jabra headset. I may have mentioned it. I brought back 20 or 24-inch iMac the other day. Again, it's old. This is old stuff. This is ancient stuff. Okay, so street value, we're talking $50. This is ancient, but I couldn't sit there, right? I mean, it's beautiful display. I mean, how can you throw it away? You know. And the most useful thing I brought back probably is Yoga 2 Pro, which happens to be exactly the laptop I have already, which I bought, I don't know, some years ago. So again, this is all dated stuff, of course, but now I have a spare laptop that I installed Linux on, and it's not a bad laptop. It's a Core i5 or i7, I don't know, SSD. I mean, it's, you know, not the latest specs, but it's pretty decent. Again, street value, we're not talking more than, you know, $200 if you were to sell it on eBay, but it comes in handy because I can dedicate it to Linux. And so anyway, again, don't tell anybody. I'm not supposed to do that. But so again, this thing presented itself, and I figured, you know, I'll give it a shot, and it's working. I think it got thrown out because there was a mechanical issue with the LiDAR. Not only was it debris that prevented it from spinning, that was easy to remove, but it has this belt drive. And, you know, when I gave it the command to turn the LiDAR on, I could hear and see sort of the motor spinning, and that silver dot is the axle there. But that black wheel there, that's part of this drive system, wasn't really moving at the same speed. So basically, there wasn't enough friction between the motor axle and this part of the pulley. So I just had to put a drop of super glue there to establish that this is just some friction fit connection, I guess, and the friction was gone. So I dropped a super glue, and the LiDAR was spinning, and yeah, everything else seems to be working. And so I'll spend a few more hours on it, at least to a point. I want to get it to a point where I can remote control it. And yeah, the only challenge, like I said, is really the fact that I can't just control the two motors independently, like, you know, on any other platform. That's one problem. Yes.
Is that interface a USB or serial or whatever? Is that interface an ASCII interface?
Yes, it's meant for interactive use. It's meant for humans to use, but, you know, a little bit of Python code, and, you know, the data comes back in ASCII. It's straightforward to parse, and so, you know, you can kind of treat it as an API. It just has a few limitations. So,
see, Chris, I think that the moral authority on you going into the dumps and grabbing stuff is you know, easily justified. If you think about it, a lot of our dumps are close to sea level, and so in the next 50 years, they're all going to end up in the ocean, and that means that all this junk is going to be floating in the ocean in 50 years. So you're doing a huge favor by taking stuff out of that dump.
there you go. Thanks. So that's all I had.
That's cool. And if you have any recommendations on where to find a dump like that around here, let us know, because
I would not let you know, because, you know, that's
Well, me
becomes
too.
a problem, and then, you know, they're gonna put up a camera. So
That was
I was
called
gonna ask,
hammers.
because
We don't
if
have
anybody
that
has
anymore.
used- I was going to ask if someone has experience with one of these platforms. I mean, it's a very common thing, right? They make some of these robots, vacuums, even specifically for kind of hacking and, you know, attaching stuff to it. So I don't know if any of you have ever, you know, tinkered with one of those vacuums.
About 5 years back. Yes.
Yeah.
but who was the guy that was in the club? Because he kind of left about James, yeah, because he was harvesting those Nidos, I think, the LiDARs, and reselling them. So you can
probably look like a Nido graveyard.
Yeah.
Well, you may remember that Get Surreal that sells those little PID controllers to control that. That's James.
Yep.
In the past, most of the club members that messed with those messed with not the Nido, but the other one. Yeah.
The original one.
Because the Roomba actually does have a pretty good API. You know,
Yeah, I think some of the Nidos are better in that regard. Again, this one just has this test interface.
Yeah. Yeah, I had one similar to the one you've got now, and I ended up just harvesting it because. So if you need a motor, Chris, let me know, and I think I might have one of those sitting around you could have.
Okay.
So like I say, but the Nito actually, I mean, not Nito,
iRobot.
the other one,
Roomba.
Roomba.
The Roomba has even has an educational version, which was just made for a
Right.
robot base.
Right.
And you see a lot of them. You see a lot of those in. In fact, I've got two of them. I won one from an Instructable contest once. What is the word? They have a new one now. The one I have, the first version. The biggest problem I have with them as a platform is really simple. It's keeping a battery in them, because you're always having to charge up the battery before you can do anything with them, because they won't stay charged.
That's what I found. I mean, in fact, I figured out how to connect the charger, but then I found out that even though I had a voltage source connected there to the charging port, it won't run any motors off of that power source. You got to have a battery in it, otherwise it won't turn any motor on. So initially I couldn't even test the thing until I rigged something up, that serves as a battery, because it just, again, different power sources and so on.
Yeah.
So, it's got to have the battery in it, which I have now. And for the longest time, I couldn't figure out, again, where the charger connects. It took me a while to realize that it's got these two metal things sticking out in the front there. That's how it connects to the charging base.
Yeah.
Right. So I got something connected there now, except for some reason it's not going into charging mode for me. There might be some sensor somewhere, maybe some magnetic sensor that tells it that it's actually in the charging base. So I'm not sure why it's not charging, but I got it all hooked up. Because that's kind of convenient, obviously, to charge it that way. But
yeah, both Nito and Roomba on various models have had problems with their charging circuit, and usually it's undersized FET that you have to replace to get them to work again. But you can Google that and find that sort of stuff. So you might check that since you got it open already. But like I said, the problem was keeping batteries in them. Now I understand that there's a source of lithium batteries for those robots, which the actual original manufacturers didn't want to touch because they burn up, and they didn't want to pay anything for people burning their house down because their robot vacuum cleaner burst into flames. So
Picky.
yeah, people are funny about that. Anyway, but you can get them on a secondary market, which you might be interested in if you wanted to pursue it further. But
yeah,
but they're not cheap.
I mean, even just the regular nickel metal hydrides, if I were to buy a battery pack with the right size batteries, I think I can get one for $20. Right now I have 10 AA's in there, and that's not the right size. So those are too small.
Well,
but again, for my testing purposes, it works. If I turn the brush on, in the voltage sags too much, and it shuts down. But so you need C. No, not C. What's the next size up from AA? Whatever that is, that's what it uses.
Yeah.
There's a mini C cell. I use a bunch of those.
Yeah.
It's smaller than a C, but bigger than AA.
Let's see, I might even have.
That's what it might be, because it's got 10 of those, 2 rows of 5. I'm not sure it would fit regular size C cells, but
I think they call them sub Cs, and actually, and I seem to remember that they would be in the Black & Decker weed whacker stuff like I had.
Here's the battery packs that you would use for that.
Well,
this came out of the one I harvested.
Yeah, now mine uses a different format, and this looks much bigger than would fit into my compartment.
Yeah. Well, one of the problems that Nito did, if you think about it, Nito's algorithm for vacuuming the floor is much more efficient because they have the LiDAR. So they don't need as big a battery as the Roomba did, because Roomba, is bouncing all over the place.
Well, the original Roomba was, right? The
Yeah.
They have the camera
Right.
that's looking up.
Yeah. So it seems to me they made the decision, well, we can put a big battery in it and it can run longer, or we could put a smaller battery because we don't need it as much. Guess which way they went? They put in a smaller battery so they don't have the same milliamp hours that you need. I'll just say those are problems that you'll run into.
I'm a big fan of not needing much and put a bigger battery in too. Do both of those.
Yeah. That was, Harold, I'm with you. That would have, as a consumer, I would have loved that. Yeah. That seems like a no-brainer, doesn't it?
Yeah.
Anyway, but that's cool. I mean, I'd love to see you do something with it.
Yeah, like I said, I mean, at least remote control. I mean, again, to do more, I'd have to tap into the LiDAR somehow, because otherwise I can't really get an update too often. I guess I could do the same thing I was doing on my Romy platform, just a little slower, where it's remote control but refuses to, let's say, crash into a wall. I suppose that should be doable, but again, the serial connection becomes a bottleneck if I try to get at the LiDAR data, right? Because it's usually there is a one serial connection just dedicated to that alone. And in this case, it's spitting it out in clear text, humanly readable. So there's a lot of overhead associated with that. And so it's using sort of probably a third, almost half the amount of bandwidth I have on that connection.
Yeah, well, it would be surprised. But you can go look at Get Surreal. That's James's website. He has a code example there for his product, which will decode at least that generation. I don't know if this is a real new one, there might be something different, but it will. He has the algorithms for decoding the Nito information that you can take it, like you said, it's a 152, what is it, 155, 200 baud serial port that's coming off the LiDAR. And so you can tap into that without too much problems. And I believe I've seen web pages on how to use the existing controller board.
Yeah, I mean, like I said, I previously purchased 2 of those LiDARs on eBay because I was planning to use it for my firefighting robot, and so I had to have 2 in case one breaks. And so I mean, there's software available for the LiDAR, definitely. I mean, it's even supported in RAWs. Again, I don't know if this is the exact same model of LiDAR or not, but I'm pretty sure I can dig that up and make that work. So it's just a question of how much time I want to spend on that platform versus going back to my Romy. So I haven't decided yet.
No, like I say though, you've already got your bumper, you already got all your
that's the thing, right?
You got all your drop switches. I mean, even if you just take the controller board and go ka-thunk and start over with just the mechanical, you've got a big head starts there.
Yeah, I'd be ashamed to junk the controller board though, because it's got all the motor drivers on it. I guess I care mainly about the wheels, but yeah, if I don't care about anything else, I guess I don't care about any of the other motor drivers that are on there. And they all have feedback. They all measure the load, and that it tells you, how many milliamps is the vacuum. The blower is sort of using, how many milliamps is the little side brush thingy sort of using. So there's a lot of feedback going on, and you can get to all that information. But much of that, I guess, is only useful if you're actually using it as a vacuum.
Right. If you use it as a robot, you just get rid of all of that. You definitely don't want that. You use the dustpan probably as maybe your new battery bed.
Yeah, that's exactly where that's the dustpan. The dustpan here, right here, because the battery compartment on the bottom, the screws are not holding very tight anymore. So yeah, that's exactly where I'm at here with the battery.
So I can't measure current with my fingers, but I think if you get rid of those little twirly motors, they use exactly 0 current, and you can calculate that. I'm just guessing. I'm being smart.
But who knows? There might be some other function that you want to do that little motor is exactly set for, and the fact that you can read back the load and the current draw is pretty cool. Even if
it's
for a
if nothing else, it's nice to sort of see a robot product, right? Doing a little teardown of an actual product, right? And the thinking that has gone into it. I mean, and there's definitely a lot going on in there.
Yeah, Chris, I don't know if you already moved past this, but this is a 10-cell pack of those mini. Those are nickel metal hydride. Those are 5,000 milliamp hour of those the sub C cells, slightly smaller than a C cell, and that's a 10-cell pack.
Well, it looks bigger, maybe just because they are arranged differently, but yeah, it looks.
See if I have a ruler.
Yeah, the Nito batteries were never that big, right? They were smaller than the Ramba batteries.
Yeah, well, they had them in sets of 2, or at least originally. And like I
Yeah,
said,
they had the way this battery pack is laid out is they're not stacked side by side, but they're kind of 2 rows of 5 end to end, not sort of side by side. So it's.
Oh, this is way too big. Oh, okay. Well, this is 4.5 by 1 3/4 by 1 3/4. So basically square.
and like I say, the one that I've got looks like it's a total of 12 18-6500 series type, or long AA's, if you want to think of it like that. That's one of them. It's got 6 in it.
Doug, I think your camera got jostled to the side. And Chris, if you're looking for new purpose for that platform, I'm thinking we have indoor contests, and we're always sweeping the damn floor. So why don't we just use your novel idea for your robot? It could sweep the floors for us.
There you go.
You could be, what do they call it in hockey? Those
Zamboni.
Yeah, Zamboni. You can be the Zamboni of the course.
Yeah, we call it like a Chris Boney.
Yeah.
There you go, and you're ready to go.
Or I could turn it into an actual Zamboni for like a backyard ice rink.
There you go.
Popular here where it gets cold, right? I mean, people do create sort of in the backyard sort of ice rinks in the winter. It'd be the right size for that.
Get a cold weather battery, and you're good.
I think it's the Home Robotics Group. One of those in California has every year they have a robots on ice competition where they just try to see if your robot can move at all on the ice. Some of them do quite well, and some of them are entertaining, to say the least.
Speaking of all these contests and things, if I could go next, I have 2 bits of information. One of them's a video. I don't mean to be short-circuiting you.
No, I'm done. Go right ahead. I'm done.
Here, I'm going to share out my screen. I'm going low-tech here. I'm not even using OBS or nothing on that to share the screen, so I can show everything. I mean, I'm going to show my entire screen. So what the heck? We're just going crazy here. This comes across my my feed on YouTube, and if you guys have seen all this already, just stop me, because I'll stop doing this. I got about 3 or 4 sections, 5 sections I want to show you, and I don't know what it is. It's all in an Asian company. I can't read the whole thing. It's Micro Mouse something or another. They published this video, and they're big into line following. So I'm just going to start the video here, and you'll see them uncover the lines. As far as my knowledge, this may be the first time these folks are seeing this thing, because they've got it all because they got it covered up and stuff.
Oh yeah.
Oh.
Kind of insane, huh?
Cakewalk.
So I think maybe those dots on next to the line are to tell the robot where the corners are, maybe?
I do not know. I mean, I didn't translate any of this, and all the audio is in a language I don't understand, and so I couldn't tell you. This is like 4 hours and 20 minutes of video, and I've got a few seconds out of it. Near as I can tell, every contestant has 3 minutes to run as many times as they can, and their best time wins. If they make it through.
So do we see any robot on this thing?
Yes,
eventually.
we see some robots. In fact, I found a couple. Like this happens. Let me go find. I got it. I wrote down some 642.
Yeah, it looks like other than the start and end there, the dots are all on the left side.
Yep. So these are. There's a lot of this, as you might imagine. I saw one that was a balance bot. It only had 2 wheels and a bunch of things held way out.
Ted, I think you're right. I think that this is more than just line following. It appears to be looking for those little boxes and using them to decide which way to turn.
Yeah, as a matter of fact, each one of those is normal. Notice it is at the start and at the end of the curve, and it's normal to the line.
Exactly. So I wonder if they even need the line.
And so,
or else it could be like skiing where you have to go through the 2 flags type thing. That's one side of the flag.
Yeah.
But it seems like cheating to tell the robot which way the line's going, doesn't it?
Yeah, it seems that way. And I have seen a bunch of these things. And this, he said, let's go a little faster, right? So you get as many runs as you want. You see the 3-minute countdown timer going on there. And a lot of these, there's always a good number of fails too. And I don't really, I care about some of those a little bit because it's going to be funny how they fail. But that's not what I'm showing today. So on this, so I think I've got a failure at 4:14. Was it 4 hours?
There's a failure.
Yeah, there's a failure.
Reverse direction.
And of course, it hits an R up there. I don't know what R means. Like I don't. Yeah, he's going the wrong way. Something, right?
Oh, he crashed on the board.
Yeah, he just went all off to the side.
Now it's upside down.
That one's done. And then I've got what's my next point here at 4. So it goes on, and you can zoom around all you want to. I'll post a link here in just 1 second up in the thing. So 4 hours and 14 minutes in, and 56 seconds.
Yeah, Harold, I found a shorter version of this, and it says that this takes place in Japan.
Okay. And you see, they get up, and this guy's about to lose his stuff because I've seen this part's getting. Let me back it up just a little bit more.
Well, you know, if anybody in the group had a companion that spoke Japanese, maybe they could translate this.
Yeah, maybe.
Yeah.
So this fella here
would be bothered.
See now,
Whoa, that's moving.
We got some pros going on here, right? And this guy did pretty well.
Wow.
And I don't know how they decide the order of who goes, but somehow the fast people go at the end. So, so that's pretty good.
17 seconds.
Yeah. Versus most of the other ones that I talked around here were in the 1.5 to 2 minute range. And
look, he just put some kind of block on with a little piece of tape. He modified his sensor in real time there. He put a little piece of tape over it.
Shave mere milliseconds off.
This is almost as fast as my simulated line follower.
No, this guy was good. He was saying like, oh, okay, man, that's good. I'm good. And I think he tries it one more time. And when he tries it this time, it fails. He runs out of battery. But
Chris, you're gonna have to get your new vacuum cleaner to do this.
Yeah. So, you know, and this has been the fastest time all day because I didn't watch all 4 hours, 20 minutes of it.
Oh, come on.
Around it, right?
You can tell us.
Yeah, I just, you know, I don't have that much. My side of my brain or something would just leaked out, I'm sure, if I did do this. If I was part of the contest, it'd be a different story. But me just sitting here and watching stuff I don't understand.
Well, Harold, how many minutes into that is this guy?
That's 4 hours and 14 minutes.
All right.
So that guy was going pretty good. So they got another guy here, and he rolls up. And this guy here, we can let some of this run a little bit. Got another guy. That guy's done, and now this is the last guy here. He rolls up in here. He got his thing right.
Is that a roll of duct tape he's got in his hand?
It's got, I don't know what it is, but they keep masking something or rubbing something a little bit and put it on there. See, he's got himself set up. I guess he's setting a sensor there, you know, so calibrating it to the black and the white, I guess.
Yeah, I wonder if they're cleaning the wheels or, you know, putting something sticky on the wheels.
Maybe.
Oh,
That was my thought, that they were sticking the wheels up a bit so they get some more grip.
Yeah.
Yeah.
And so this fella here, remember the last guy was like 12 seconds, right?
Thought he was 17.
No, he got to 12.
The second run was 12.
Yeah.
Past 12 already.
So this is this guy's first run, and he's already whooping, you know, 99% of the rest of the crowd, right? So that's awesome. And I think we'll let this run just a little. We might as well. I can try to zoom around, but at the time scale and moving the time scale around when I'm looking for minutes over hours and multiple hours, driving with a mouse is just pretty hard. I'm not sure all that lattice work is doing for him there, but there's a bunch of sensors on it, right? He zoomed it up a little bit.
It looks like he's putting that tape only on the sticky stuff only on one side of the robot.
And he just beat the other guy.
He's not doing it on all four wheels. I mean, both wheels.
Yeah, but wait for it. Wait for it. He has one more run in him.
11.4 seconds.
Yeah, he's got 11 minutes and 10, 12, 13 seconds left. You know, he can run. If he can do it in 11 seconds, he can run a lot faster. He can run a bunch of these things, right? So he's pretty much already won. I'm guessing he's won because I can't understand everything, but I think
Harold, I think that roll that he holds in his hand is a moistened roll of foam or something. He's just using it to clean the wheels.
Maybe.
And he turned it up to 11 on this one.
Whoa.
Damn. It's hard to imagine it even staying on the ground at that speed.
That was almost a teleport.
Yeah. And that's the end of that video. That's impressive, right? And I get a lot of these videos. Some of them are like 3 or 4 years old. Some of them are like within the last year or something. Obviously, we're not going to get any 2020 action going on here. And some of them are maze followers, and some of them are other things. And these little bitty micro mouse things, they just zip like it's crazy.
Yeah, I've seen some of the mazes they have, and it's amazing how they can go through that maze. They'll cut corners and go diagonally in places, and
yeah. How do they know? You know, how do they that all the algorithms and stuff they got going on there? And not only do they, I've seen a couple of them that don't do they solve the maze to get to the center. It pauses like 3 seconds and then comes back out. It like somehow either remembers or figures its way back out and comes back to the start line, and that's part of the test that they're near as I can tell.
I think that's what Ted was talking about. It's in the subsequent journeys after they've mapped it out the first time that you see them cutting corners and really running fast and so forth. So it's like they map it with the first run and figure out the best route.
I mean, these things are zipping in like crazy, and that's one of the things I had to show. And the only other thing that I had was, by the way, just like I promised, the link to that video is now in the chat. So you can watch all 4 hours and 20 minutes of it yourself for your pleasure.
See, I think what really should happen now is the DPRG should challenge the Japanese Robot Club to a competition. I can say that safely from New Zealand, right?
Sure, embarrassing.
Well, I can tell you from experience at the annual, or what used to be annual firefighting contest in where I'm from in Connecticut, the between the teams from Indonesia, China, Israel, they just beat the crap out of everybody else.
Wow. The only other cool thing going on in the Herald Life these days is at work, it's awesome to feel needed. I felt extremely needed today in this last week as I went back in the office, and I got some questions going on. I'm on one team, and we're building this thing to help distribute nurses and doctors with the pandemic and everything from where they are to get them licensed to practice in some other place and make it easy. And that's going great. But I got a weird call or a weird question about a week and a half ago. Asked me some questions about some IoT stuff, and I it's not a done deal yet, but we have a project at in improving, and I think from everybody, what everybody's told me, as soon as this project hits somebody's desk and it got to go on, let's say Harold has to be on this team. So it's dealing with Raspberry Pis, RFID, IoT. They're talking MQTT and AMPQ and all those sorts of stuff for ingesting data and doing stuff and scanning product. I looked at some spec sheets of some of the hardware they're looking at using, and one of those will read 1,100 RFIDs a second. I have no idea what they're doing with it, but I'm like, dude, that's pretty impressive. I don't care who you are. 1,100 RFIDs a second, you got some stuff moving, you know. So and I don't know when the project is already kind of in discovery. It's in discovery right now. So when it actually fires up proper, I don't know. But I think I'll get to work on that project. And so all these last few years that I've been mucking with this stuff, now I guess I got to put the money where the mouth is to actually say that I can do some of these things, right?
Now you can get paid for it.
And get paid for it. It's a little scary because I've been playing with all this stuff. I've done a bunch of workshops, but then learning something in a workshop and some trials that you've done yourself versus a production thing, two different levels of stuff, right? And I know Carl knows all about that. So, and maybe some more of you as well. So that's a good thing, though. It should be fun. We'll see how far it goes. And that's all I've got. That's all I've got.
Cool. Cool.
Good luck with that.
Thank you very much.
Okay, who wants to jump in next? Okay, it's looking quiet, so I'll take this opportunity. So I've been picking away and kind of on the fence as to whether I'll do this outdoor competition or not, just because I don't have a whole lot of time. But I got this help from David Anderson. He gave me his son's old outdoor RC racer. So I have a question and an observation that came from this. And the observation is first interesting thing about servos. If I can get the microphone and the camera together. Okay, so I had these servos I picked up a while back, and how's that for a bench? So one of these servos, this is a servo that I had for a long time in stock, and this is the one that just came in over the weekend because of what I found on this one. And, whoops. Okay, we got to work on this somehow. But you'll see that if you look closely, I think that's coming across. You see when I move it kind of smoothly on the servo tester, it works okay. But then when I reverse direction, there's a kind of a dead band before the other one kicks in. And you guys see that?
Yeah.
That really bothers me. I mean, that dead band, because I want something, it's for steering servo. So the last thing I want is to add dead band to an already messed up steering thing. So
yeah, probably the pot's going bad on it.
Yeah, that's what I figured. The pot's misaligned inside. So anyhow, I got another one of these, a new set from Amazon, $5 each, pretty crazy. And wouldn't you know, but it drops straight inside that little guy. So that problem is now fixed, and it's got a new steering servo. Now the next question is, it's got a brushed motor, and I can guess at what the voltage was on this thing, but I'm kind of wondering. So, because I got this really nice speed controller, nice looking Hobbywing 1080 something or other, and it's made for crawlers. It's really programmable, and it'll run on a 2S or a 3S pack. So I'm trying to figure out. I'd really like to stick with a 3S pack on this because I've got 3S on the other stuff I've got. but I'm wondering if I'm going to risk blowing up the motor. So,
wasn't 7.2 volts a common voltage for battery packs? That
yeah, I think it was of a certain generation, right? Not nickel metal hydride, 7 point something volts.
Right.
But I'm wondering, I mean, since it's pulse width modulated, I mean, what could the failure modes be if I just give it a 3S pack and a lower duty, a different duty cycle?
Should be the same thing.
Yeah, I do that all the time. In fact, I've doubled the voltage a lot and not had any problems. The only thing I worry about is maybe the insulation breaks down with the higher voltage, but I've never had that happen.
I gotta figure that the dielectric could withstand a pretty wide range, I gotta guess, but I figured it'd be mostly a heating failure mode, if anything.
Yeah, that's my guess.
The wire coating.
Well, from what I remember from all the radio control cars that I've dealt with back in the 80s, it all came down to what the speed control could handle. And usually it was either a 7.2 volt or a 8.4 volt, were what those old speed controllers could do. And then when you got into the newer stuff, like for rock crawling, like what you're talking about, then you could get up into the 12 volts and stuff like that. So I think your motor will be fine. I think it all depends on the FETs in your speed control.
And that's what just amazed me. I've been watching speed controls just advance over the years, not very closely, but I picked this thing up for $40 on Amazon, and it's got a little control. It's got a little programmer in there, and it's got a whole bunch of parameters you can change. It'll do like 80 amps, I think, continuous.
Yeah.
And it's just pretty wild, I think, what you can do in a size of a servo.
Yeah. Probably even has a BEC built in.
Oh yeah. It has a 6 volt 3 amp output for your servos.
Yep.
Got a nice little power switch built in. So and it comes with the XT60 connector.
Yeah, and the beautiful thing about those electronic speed controls is that they just plug right in, and you can control them just as the same way you would a regular servo.
Yeah.
You don't have to worry about like your stepper motor controls or your H bridge or anything like that. It's you just give it the same commands you would as a servo.
Yeah, I mean, it makes me wonder why would, aside from maybe cost, why would we even mess with these little H bridge boards when you could just get one of these and drive it with PWM?
Mm-hmm.
I think most of them are only one channel, right? It's hard. I mean, it's a little hard, less common for them to be multi-channel. Is that correct?
Yeah,
you
there are some $20 ones.
Yeah, you can get the dual channel ones that have built-in mixing and everything that the combat robot guys use, and you can get them low current for maybe $30-$35, and then once you start getting into the higher current stuff, then you're talking about hundreds and more. But what I did, not to take over from you, Carl, I'm sorry.
No, that was it for me. I'm done actually. So take over.
That RoboClaw that Ray and I have, that RoboClaw that Ray and I have does all that too. Does that RC control stuff. Anyway, go ahead.
Okay, go ahead.
I know this real well, but it was my first attempts at trying to do some mixing with skid steering. Sorry, and what I did was I got a V-tail mixer for a rear control plane, and then plugged two speed controls into it, so I could use a trigger type controller rather than a stick type controller, because I wanted to have the steering wheel the trigger type, and that was just my proof of concept. It worked really pretty good. I got pull the trigger, both tracks run at the same speed, turn the steering wheel, and it turns and it does its thing. But yeah, it was pretty cheap. I think the V-tail mixer was, I don't know, maybe $15 on Amazon, and then a couple of cheap speed controls, super cheap speed controls. I'm only running well, it's two lithium-ion batteries in series, so it's 8.4 volts at max. But yeah, it was just my proof of concept to get some skid steering with a trigger type radio control.
Looks good. I think David is trying to show something here. You're muted. David, you're muted.
David Eckley?
I'm sorry, Anderson.
Could have been muted or could have just been not saying anything.
The hand motions.
Self-muting.
This, I don't know if you guys know what he's talking about. This is the kind of controller. This is what almost all RC race car guys use. So you have a trigger that basically braking is, they don't actually ever drive backwards. So braking is one direction and acceleration is the other. And then you have a steering wheel.
No, some drive backwards. Mine drives backwards.
Yeah.
Yeah, for actual like sanctioned racing, you can only have a forward only speed control, but you can get the reversible ones and the trigger type controllers will do reverse.
The guys who race though, they don't drive in reverse. You even see them; they'll bump into something. Somebody have to run off onto the track and push it back for them.
Yeah, that's part of the rules is they can't have reversible speed control.
And you know, the ones that are reversible have this, for robotics purposes, this real annoying thing. They're afraid you're going to tear it up by suddenly going from forward into reverse. And so they force a little pause in the middle. You can't actually directly go from forward to reverse. So that, for example, you couldn't build a balancing robot out of one of those. For our purposes, it's kind of annoying.
Yeah.
Yeah. Donkey Car had that issue as well.
Yep, it does.
Huh. I thought that was one of the settings that, like on this one I got, that you could change. Huh.
This is what a real transmitter looks like.
Right. Okay, that raises another question. Spectrum, Futaba, or some other? Go.
Well, Futaba's been around forever. Yeah, they've been around, since like at least the 70s or longer.
Yeah. I mean, I have one from the 70s. It's time to replace it.
Yeah.
What is it?
I'd go with a newer, cheap model.
Cheap one?
Yeah. I mean, wait, let me see what mine is.
Spectrum. Okay, Spectrum. Because I was thinking some of these, like there's the Real Flight. I have a really ancient version of the Real Flight simulator, and I know that you could use an interlink of some kind and use your real world controller with the PC simulator. I didn't know if it crossed brands very well. Anyhow, Robot Club, I'm asking RC questions. I should shut up now.
Yeah, my transmitter is a high tech, and it was it was a nice cheap one. I've had it for 15 years at least, and it still works just fine. So it doesn't have a whole lot of features, but it was also I think like $65.
Yeah.
When I first started flying, we basically had a radio and transmitter for each airplane. It wasn't that easy to move a transmitter from one airplane to another. And but when we went to these modern Wi-Fi style, frequency hopping transmitters, you really only need one transmitter. And so they come with internal software where you can set them up for multiple airplanes.
Yeah.
And so you go ahead and spend $500 or $600 on the transmitter, and you only need one of them. And they also, these modern transmitters can do all kinds of mixing, and they can, on the helicopters, we generally fly an exponential function on the sticks so that the sticks don't do very much around the center, but they do a whole lot more as you move away from the center. And you can control that exponential function exactly what its shape is, and they're really sophisticated. I don't know that I'm a good enough flyer. I don't know. You know, it's like I'm a violin player, but I don't need a Stradivarius.
I'm with you on that.
Will do.
Well, okay, so there's another question on this one, which is that, like David, you showed the car style controller transmitter with a steering wheel and a trigger, but I'm just used to the 2 sticks for old glider, and I'm just wondering, I mean, why wouldn't I just use 2 sticks for a robot to drive it around? Is there that much better UI, do you think, with the trigger and the steering wheel?
I think it depends on the design of your robot. Because I mean, depending on, I mean, yeah, I think the design of your robot and what you're used to. If you want to, like for skid steering, if you want to be able to control, you know, each side with a different stick, my thought was I wanted it to, I wanted to have the feel of the way that a car turns. And so I wanted to use the trigger type controller. Plus, I already had it, but it's just what I'm more comfortable with.
Well, my experience on that is limited, but I can tell you that the guys who race, you know, those cars, they're doing 35, 40 miles an hour. They all use that trigger controller because I think that it's just much easier to make tiny adjustments to the steering of the car when you're going 40 miles an hour. And that's probably something we don't need to do. Also, if you have, you know, a programmable transmitter, then you could drive the thing around like a tank, 1 stick on each, or you could do mixing and say, put it all on 1 stick with the velocity fore and aft and rotation left and right. My transmitter, the throttle is not spring loaded. All the others are, but it doesn't center because you wouldn't want it to. So to use a left and right stick is a little odd because the left one won't be spring loaded. So it'll be a little different than the right one. But you can do all that mixing, you know. We had on the radio control camera car that we used to drive around SMU, we had it set up so that when the camera itself was on a XY mount, and so when you steered, when you're going at high speed, the camera would actually tilt in the direction you're steering and look down a little bit so you could see corners and see what the wheel was going to hit. So the camera was just steered, and we just did that by mixing in the transmitter.
This is like the headlights on a Citroen.
Yeah.
Or Hudson.
I don't know if that helps any, Carl.
Yeah, no, it's just stuff to think about.
I think these are, I mean, to show you how old this is.
Oh, I saw that antenna. That's a dead giveaway right there. That says illegal radio spectrum to begin with, all over, right? So,
well, you know, back in those days when you went to a competition, they have this big board.
Flags.
Flags. And
Yeah.
you got to take one off and you got to clip it onto your antenna.
Yeah.
Yeah, and if you didn't have a flag, if you didn't have the clip on your antenna, you didn't turn on your receiver. I mean, your transmitter.
Or if you did, you made somebody's airplane crash.
Yeah.
I was so bummed in this. Was it the 70s or the 80s when the FCC juggled the spectrum around and overnight made all of those radios illegal?
Well, everybody had to move to the, was it 74?
74 megahertz, something rather.
74 megahertz.
What was it again,
I
Ian?
think it was 74 megahertz.
74 megahertz, yeah.
Yeah.
But
And then
these
you
are
get-
so much better. These, you know, the ones that do the spectrum hopping, they're just solid as a rock. You never lose the signal. They're just great. I think you can have like 80 all flying at once.
Yeah, mine is 75.650 megahertz.
Yeah, that's telling.
No.
I got 72 in the attic, which I assembled in about 1972 from a kit. So I can with pride say I built my first servo. It has 64 parts and a 1-inch square board. That's
No,
cool.
Ian, this one is a 27.1 something megahertz.
20, yeah. That was more common for the ground, and then the 72 was for the planes. Unless you're a ham, then you could use 50.
Yeah, this one is ancient. It's a 75.470 megahertz. I don't know if you can see it or not. It's a Futaba.
Yeah.
Yep. Very old.
You know, Carl, I think all of those radios probably have the same chipset inside of them.
Yeah.
And if you're going to buy a modern one, a lot of it is just what features you want.
Basically.
I think if I was going to go out and buy one now, I'd get one of the ones that have the telemetry package that allows you to get signals back from your airplane or your robot or whatever. Also, you want to, if you're going to fly helicopters, I should put that caveat. You want to pay money for the gimbals, for the sticks.
Oh, no doubt.
You want
Right.
expensive sticks.
Yeah.
And it used to be like you could take the spring on or off the joystick, right? So for the throttle, you could, if you wanted to set up for throttle, you could take the spring off. It would hold position. Or if you wanted to use it for something else, like ailerons or something, you could put a spring inside the transmitter. Is that common?
I did that very thing because I wanted to, back in the day, when I was flying RC, I didn't want to be like everybody else. And so they were all flying what we called on the day mode 2, where the elevator and the ailerons are on one stick, and on the other you had your throttle. So I switched it so that I had elevators here and ailerons over here. So there were 2 different sticks. So I thought I could be like, I don't know, cooler or something. I did pretty good flying right until I forgot to put enough rubber bands on the top of my plane. And
whoops.
Yeah, the wing came down very softly. The rest of it not so much.
Well, Harold, on this transmitter here, one of the functions that you go in and set, you can tell it what mode you want to be on, which functions you want to be on which sticks, although pretty much everybody flies as you described.
Yeah.
However, there are some small subset of helicopter pilots that would like the rudder, which is the left-right axis on your left hand. They would like that stick to control the tail rather than the nose. Meaning when you push that stick to the right, the tail goes to the right.
Got it.
The nose goes to the right. To me, that's totally backwards. And if you handed me a transmitter, which has happened before, I would be well served to get the thing back down on the ground.
Well, you just turn the thing upside down and cross your hands, you'd be all right, right?
Yeah.
Well, it's kind of like the Macintosh mouse. I mean, it's scrolling is upside down by default.
Yeah, there's a big yeah. I'm with you, Murray, and I get told I'm wrong all the time. No, you're just looking at it wrong. It's your fault. I'm like, oh, okay, yeah.
It's the counterculture. Take a good standard and flip it backwards just to be different.
Just to be different. I mean, well, I'm not getting to that big old debate, but their point is a solid point. It's just that that's not how we've been using. Much like, you pull back to go up and push forward to go down, but now kids don't do that in their games. It's push up to go up and pull down to go down when they're doing all their first-person shooters, and that F's me up every time I jump on the game because I'm doing the other way. I'm doing aircraft control, not not that I'm very good at those games, but
Harold, here's another one. Gnome interface on Ubuntu. In the last year or so, they've decided that you're no longer going to get icons on the desktop, and if you do, you can't move them around. Duh.
I mean, who makes these decisions without checking with us first, Mary? Who do they think they are?
I've researched this, actually, not to take us off the robot topic too far, but I've researched this a fair bit, and it turns out it was some executive in the Gnome team that decided that they didn't want to have desktop icons because they thought that they were counterintuitive. Like,
well, what right do they have to make arbitrary changes to this free software that they're giving to us?
Well, the only thing is that actually there's millions and millions and millions of people using that free software, and they basically went against the wishes of the entire community to do that.
Oh, this is like redoing Star Wars movies.
Yeah. Well, I've had to go away from using Gnome simply because I can't use it because I usually use a desktop and I want a desktop. So they're forcing people off their own platform. So.
I've got 2 things right. Hand shot first, and Epstein didn't kill himself. I'm just saying.
Yeah.
On shot first. Oh, yeah.
gods. All right, so who wants to go next? We've
go.
gotten way off Robot Club here. Ray?
Yep. Well, this is the first time I've ever incorporated a safety feature into one of my little platforms here. Let's see, where is it? I actually have whoops, wrong direction. Yeah. Okay. Anyway, I got I got the rat's nest on an actual board now. So I've got several different modules that are tied down and all. I use wire wrap wire. I don't know if this light is going to make this any better. Yeah, maybe a little bit. Anyway, so I've got two DC to DC converters, this one and this one, and I needed two because this servo, which is like a 30 kilogram servo, actually doesn't generate 30 kilograms unless you run it at 6.8 volts, and that was going to be too much for the ESP LoRa board, which really wants maybe 5.5 at the most. I've got this is another module that's just a pretty high power bridge to drive the linear actuator, which is right there, and so a relay here it's just a relay module. It's a little difficult to see. It's in behind this other module, but that's to cut off the ignition on the tractor, so that when I'm gonna pin myself there. Yeah. Anyway, so to cut off the ignition on the tractor in case bad things happen. So I've got I can turn them on. I've got the transmitter and the receiver working, and gamma turn on. There we go. Get that turned on. So I can move the. Let's see I don't know if you can see the servo moving. I've got just a big, huge joystick and a couple buttons on it. It's one of those old, I don't know, IBM compact computer joysticks. So it's got, one joystick and two buttons on it. And the red button, if I press that, it cuts off the ignition. So that's always a good safety feature to have. And the throttle is the 30 kilogram servo. And I can move that around now. And then the steering part is that other linear actuator. And I can see this module has a display on it, so I can see what it's receiving and the RSSI, the signal strength. So that's all working, and now all I have to do is get it on the tractor, and I should be able to drive it around, RC. Or with radio controlled.
Does that linear actuator have any kind of limit switches? Are you going to put that on the steering?
Yeah, it's got limit switches and it's got a potentiometer for feedback.
Oh,
so I'm actually
cool. Yeah.
These three wires on the ESP32 LoRa module.
So you actually know the position of the.
Yeah. So just doing A to D conversion on the analog voltage, and it gives me position feedback, and I use that to to position it, like if I push the stick, and this one is self-centering. Whoops. If I push it, whoops. wrong direction. If I let it go, it snaps back to, the straight position. So I don't know if I call that snapping back. It moves back. It doesn't move very fast. But so that's all working. And I don't know. I've been a real proponent of LoRa, the transmission. And it seems like it goes anywhere. It goes through walls. It goes around metal buildings. Goes underneath a solar array. And there's still quite a bit of budget left. Here it's only like at minus 20 dB, but you get outside and it'll go down. But you have a budget of like 150 dB, so it's pretty good. Anyway, that's oh yeah, there was one other safety feature that I've never had on. I don't have this wired in yet because I've got to wire it into the tractor, but it's a mushroom button switch, so if I can catch up with the thing without cutting my feet off, smack the mushroom button and shut it off. Anyway,
multiple safety features, Ray.
In the
Ray,
spot.
did you put a link for that? I think maybe last session, you did put a link for that LoRa com link. Is that right?
Where you could buy it, you mean?
Yeah, and just specs and stuff.
Oh, okay. Yeah, got it from Banggood. Yeah, well, I wasn't here last week, but I think I did the other week. But I could probably find it pretty quick.
It all flows together.
Yep. Yeah, I can look that up in the meantime.
Thank you.
All right,
Anyway,
Ray, pretty good. Yeah,
that's all that I got. I was
Very
looking
nice.
for the link.
Okay. Well, in the meantime, I'm going to stretch this subject a little bit since we went. I did find the other one. So, Doug, here's the servo version of it, which I had built a couple years back. So, actually, right now it's in parts, but it's unfortunately black. But anyway, the two servos are there. It was on Thingiverse way back when, where basically it was 3D printed around the servos. So, yeah.
Those servos have enough power to get it going?
Oh, yeah. Well, this it does. It's not all that big, as you can see. It's super small and light. And then basically it has real, 3D printed wheels with little rubber, on the thing on there. So they just snap into the groove. And then this was the battery box. So you was sliding the batteries in there. And then this was where the Adreno board would go on top there. And then this was where I had the ping sensor on the front. So it's, and it's not all that big. It's like hand size. But it did pretty good back then. It's slow though, that's the key. But that benefit is that it did move around in that.
Well, that's interesting. I'm waiting to see if this Instructables robot's going to be functional after I get it together.
It should work about the same, I was thinking.
Yeah.
So, yeah.
Yeah, if you look on the Banggood, banggood.com, if you just put in that number 1239769, it'll pull up the ones that I bought. They're what is it? Yeah, it's TTGo is the brand name. Let's see if I can show that. TTGo. And you can print out, I always find that useful to print out kind of a pin out of it so that when you assign things to it, you can keep track of which pins you've used for what, all that stuff. Anyway.
Cool, thanks. Yeah. All right. And let's see, who have we missed? Anybody have some other items yet? Murray, you have any luck this week?
Well, I think as I reported last week, I've given up on the club robot idea, but so I've been kind of refocusing on getting my robot running again, and that so that comes down to software, and I have actually got a largely functioning message bus finally. It seems to work, and so what I'm doing now is trying to reconnect it because it's just all mocked. So what I'm now trying to do is reconnect it first with my gamepad, and then I'll eventually, because it's basically a publish subscribe model. So the publishers are the things that generate events, which would be like the sensors, and the subscribers would be like the motor controller. In this case, actually the controller, which then sends behaviors, or actually runs behaviors, which then talks to the motor controller. So that's kind of what I'm starting to do now. It's a largely complicated thing I've taken on, guys. I mean, it's not something that just happens in a week, you know. So that's what I'm doing, and yeah.
So you'll have it done by next week then.
I'm now building out a little tiny thing that'll hold 5 infrared sensors and 3 switches, so I don't actually have to use my robot. You know, this is my front bumper sensor mock. So I'm kind of in that process. Nothing to report. No gold stars. Sorry.
Yeah. I haven't broken any motors since last week.
That's progress.
It's progress. I did take a lot of advice from the group about, you know, how to not break motors. And let's see, how do I share here?
I don't think anybody has gotten a gold star this week.
Oh, you missed him. Pat let us off quite early with a differential indoor, good-sized one running around in his living room. So he got the gold star before you got in.
All right, good.
Yeah.
And David, not you?
One.
So this is my my motor driver board that I just modified, and I just added this part right here. This is actually a current sense amplifier, and I've got a little 120 milliohm current sense resistor here on the negative side of the motor output. So that's going to feed into my my PIC, where I'll be able to sense the current, be able to either shut down or limit the current, the PWM to my motor driver. So that's all I had.
Cool.
So I'm still, so I just ordered my printed circuit board from Oshpar.
You said that was what's the resolution on that little resistor?
The resolution or the
resistance? I'm sorry.
120 milliohms.
Milliohms. So,
Yeah.
and what's the voltage there?
Let's see. Oh, let me bring that. Hang on a second. Let me bring it back up. Let me check it real quick. I can. Should be 0.09 volts. So that current sense amplifier has a gain of 20. So that gives me anywhere from 0 to 1.8 volts, which is great because the PIC, low power PIC that I'm running can measure up to 2.048 volts. So that's just waiting for that board to come in, and I'll do some more, see if I can avoid doing more damage. I'm just playing with it today and found out that I messed up on some of my measurements and tolerances, and I almost broke a motor today. Because as I got to the end of the range of motion, I could hear it grinding to a halt. So I shut it down real quick.
I think almost doesn't count.
Yeah, So yeah, I went in and found that I'd slightly mismeasured the thickness of my printed circuit board that's part of that linear actuator. So I went in and made some corrections to my 3D model and printed another part. Now it seems to be working okay.
So if you get a gold star for showing your robot moving, do you get a black star for burning up motors?
Yeah, it should be something other than a star, don't you think?
That seems fair.
2 gold stars, yeah.
I don't know. I'm hearing good progress because you've gone from motors per week to weeks per motor. That's a good progress. Cool. Let's see.
There's those Eagle Tree loggers. I put a link up one time, and of course they're trying to log massive amounts of current at fairly high voltages. But I was looking at them one time, and they were sort of bragging on the fact that they don't use a real low resistance to measure the current, but rather they're doing it with something like a Hall effect sensor or something like that.
Oh yeah, that's one of the things I considered, but the chip shortage that they have right now is making it really hard to get a Hall effect current sensor, and even if you do, they're a lot more costly than just putting a current sense.
Oh yeah. Well, and as I say, on those big loggers, I think they're concerned about not wanting to affect the loads that they're measuring.
Mm-hmm.
Yeah, I was looking at, let's see, what was it? ACS 723 was the part for a Hall effect current sensor. And normally they cost somewhere around, I think it's like somewhere around $8 each. Might have been less, but even if I could, I looked at all the suppliers and nobody has them right now, and they are listing something like months lead time of getting any.
Who would have thought that the world could run out of stuff?
Yeah.
Well,
Chips especially.
The nice thing about those Hall effect sensors is they completely decouple your motor power circuit from the rest of your board.
Yes.
Well, I see here. I looked that up. I find them on Amazon, and Mauser has them, and so forth. This looks like even SparkFun has them.
Yep. Palulu.
And it looks like about the $10 range, but you're saying that's only when they're available.
Right.
Yeah.
They have them listed, but then try to order one.
Yeah, and unfortunately, also the ones that require a 5-volt power supply are more common than the 3 volts, and my board is currently running off, 3.3 volts. So.
Yeah. Probably with the chip shortage, it's who has the most money to to pay for getting their chips produced over somebody else, the competition. So.
Well, that kind of makes me wonder if the prices are going to start going up dramatically.
Yep.
I don't know if anybody else has been ordering any parts lately to see if they see any price changes.
I got a quote today at work for a new big data server they want to buy, and the guy who wrote the quote was a little apologetic about the price, and he invoked the chip shortage.
Yeah.
Sometimes you wonder, though.
Hey, I'd love to help you, but this old football injury,
Hey, David, you'd mentioned Eagle Tree Systems several times before, and I happened to go look the other day, and it looks like they've actually closed.
Bummer.
Eagle Tree Systems, last September, it seems.
Bummer.
Yeah.
It's a real neat little gadget. I've got a couple of them.
Yeah, they're like gold now. Better take
Well, I
care
wonder
of
if that's because they were, some other Chinese manufacturer out competed. I can't imagine that market has gone away. It's a huge thing for the helicopter guys to be able to log all their parameters.
I bet. No, it just says after 18 years of fun with fellow pilots, they'll be closing. And oh well.
Bummer.
Yeah.
Just like Tanner's.
You know, all the good ones. All the good ones.
You know what it is? They're following us around. And then when they see where we're purchasing from,
Then shut them down. Yeah. Okay, so who's next? Anyone else? It's a quiet night.
Carl?
Would not have guessed it.
Carl,
Doug.
can you, oh yeah.
Happy
Okay.
Sunday. Rules apply as always. If you don't have a sense of humor, please just keep scrolling. So we'll look at the appointment with her gynecologist. After her examination.
Oh, okay, we're gonna mute Harold.
Yeah, okay. Okay, Carl, I came across something on Instructables this week.
Yeah.
That was something I hadn't really ever thought about.
I muted my microphone before I even poked it. I don't know how the hell that happened.
I muted your mic.
Okay.
I physically clicked the "you should not use this microphone" to go. So I don't know what's going on there because I thought I had muted up. I have a father-in-law that sends me funny stuff all the time, and so yeah.
Some kind of kinky porn, I think.
Leave that alone.
Okay, so anyway, on the Instructables, there was an interesting Instructable about ultrasonic modules. And they're doing, this gentleman is doing something a little different. I'm going to try to present now. All right, so now I don't know what's going on, so you guys are going to have to help me with this. All right, so he's taking two ultrasonics. See if I can get his picture of it. Oh, come on. No, I'm going to show it to me. I'm going to have to do this. All right, so if you look on his little tin can here or his plate, he's okay. No, excuse me, wrong. Okay.
So he's got a servo.
Give me a second. That's the wrong one. Here it is. Okay, so you see, do you see how he's got two sensors mounted? And he has them, they're at a slight angle. And the two sensors are set up so they overlap. Now, he's not really trying to find a distance. Let me see if I can. Okay, so here you can kind of see. No, that's not it. Sorry, guys. Trying to find this. It's not very, okay. Well, let's just listen to him. And he's mounting them.
Doug, we're not hearing anything.
Oh, okay. Well, what he's doing is not a distance measurement. It's a tracker. He's actually tracking the location of this thing that he's moving out. He's going to show it here in a second. He's got a pole and he's tracking it going back and forth. And what he's done is he's tapped off the receiver output of the receiver. Okay, so he's got a magnitude that he's looking at. All right, come on. Okay, so now if you look at his, okay, come on, let me do it. Sorry guys, trying to get this, find it, the best way to talk about it. Let's see if we. So if you think of it, what he's doing is he's got the two slightly set at an angle. So when he fires one off, he gets a magnitude off of the green one, and he gets a magnitude off of the blue one. And then he's essentially taking the difference. So he gets this red response. All right. And as you can see here, there's a minimum. And he's using that to point the two sensors so he can track an object by he fires one off and then he fires the next one off. He does a subtraction. And if the object is fairly close, with ultrasonic, he's getting a fairly quick response, so he can do it. All right, now, so he goes through and he points out that, well, when you do this, the two sensors are not going to be matched. All right. So like what he does is he uses software essentially to adjust so they're equal when they're both getting the target. So, and this is the signal which is the difference pattern. All right. And this guy here kind of gives them is another way to look at this guy. So he's using this guy, telling it, well, okay, you got it here at 20 degrees. You need to turn this way. Okay, you need to go to the that way. Let's see. And I guess this, I'm not sure exactly how. I can say this data looks like it's just one side flipped over.
Can you put that on the website on the list?
Chat.
I put a link in there.
Yeah, I'll put a link in there.
Okay.
He's got two. One where this is where he's building the tracker. And that first one that I showed you, which I said, oh, that's the wrong one. That's the one where he talks about how he modifies this. And let's see if I can.
That's really, really cute concept.
Yeah, well, that's what I'm saying. I hadn't quite looked at it. Okay. So here he's using, let's see if we can find out. So you have to be kind of careful. I noticed that he labels this to be micro controller unit pin 9, but if you follow that, you'll see it's pin 10. I think he might be actually using pin 9. Well, no, he talks in the text where he makes the wire. Let me see if I can show you that. Okay, here you can see the modification, and it's done by adding a jumper wire from the collector of this particular transistor. Now, the one he's using is specifically is this Grove from Seed with many E's Studio unit. They cost $4.20 and take about 3 weeks to get to you, and you have to pay shipping on them. So they're more expensive than the standard HS04. HC-SR04, but if you look at the SR04, there's a similar transistor that's on that one. So you might take a little time to see if I can get what he's doing. This one's really nice because the Grove connector actually has an NC pin, so he just does it to the NC pin, and now he has the output. So this is a neat solution to it. Let's see. Anyway, so you need 2 of these links, and I'll put them in. This is the first one talks about modifying the ultrasonic. Let's see, how do I get to?
Was he wire or the open collectors or something? Was he wire oring the collectors so he could get
No, I think he's doing the actual difference. I think he's
the
doing the difference in the, or maybe Ray, I might not have understood you quite correctly. I think the difference of the two is being done in his software. Okay, and he has an example program. Okay. See if I can get this other guy. This is it. Yeah. So he's calling it a Monopulse Tracker. Yeah, I guess what I was thinking is I hadn't really ever thought of using two ultrasonic sensors as a tracker per se. So he doesn't know exactly where his obstacle is. Yeah, I mean, he doesn't know if it's right up in front of him or if he's out further. Obviously, you should be able to extract that information just using the normal just calculating like you would with the digital output. So he's added essentially an analog output that I think is just the magnitude of the return signal. And anyway, it's an idea, and I may be not completely understanding exactly what he's doing, but I think I am. Take a read at it. It's just something that's a little different than what we usually see. Okay, so let me so that was something that I saw this week. How do I stop? Oh, here it is. All right.
Doug, do you think that would be possible with those little time of flight sensors rather than ultrasonic, or does it rely on the ultrasonics?
Well, I think the spread of the ultrasonic, the cone, probably gives you, makes it, otherwise you've got signal, when you subtract one from the other and get the difference, I think you're going to get that nice dip. Where if you only had two spots.
But that's the thing we've been finding out. I think David and other people have been finding out is that actually some of these aren't spots, that they've got like somewhere between a 15 and a 20% or 25% spread at distance, I think.
If I let me look at what he's saying. His
Although it's not like an ultrasonic, I realize. I think that David was saying they're almost holographic or something like that.
Yeah, Murray, a quick scan hints that he's pulling the output from the sensor directly, and he's doing something with it. So
okay, that answers my question.
Yeah, because you're not going to do that in time of flight.
No,
you're not going to.
But there is a similar kind of tracker project on the tiny, I think it's the tiny LiDAR. They have a project. I was going to build it. I got the parts, but they have 3 of the time of flight sensors on a 2-axis gimbal, and it can track in 2 dimensions, a hand or something. So I'll find that link and put it in the chat.
I'd be quite interested in that because there's a number of different time of flight sensors out there, and some of them are for medium range, and some are like 1.5 meters. But at that sort of medium range, if your robot's not going that fast, and you're coming upon an obstacle, it'd be nice to be able to track movement around 1 meter, distance.
Yeah.
And the time of flight, of course, are really small and light, so it'd be easy to put 2 of them or even 3 of them on a servo.
Yeah.
If you're trying to determine where a stationary object is, there's David has done some things. I know I've done it with one sensor where you just essentially you go until you pick it up and you go until you lose it. And then you know that your cone's about 40 and you take the 2 parts. And David does something similar with the 2 sensors that he has where he moves it till he picks it up and loses it on the other. So if you're looking at a stationary sensor, that's another way of doing it. And this might really be just another way of doing what David's doing with his 2 sensors. Right. But the thing that's kind of cool on this guy, he's moving this thing back and forth, and his little thing is and he says that he makes the statement that if he leaves it in a stationary location, is that his sensor will jitter back and forth as it tries to find it. So maybe a little different. Anyway, it's just something that I thought that was interesting. I hadn't really thought about doing that, and it might have some value to somebody.
Well, even with a narrow beam, you could do something like, and I've done this on a little robot that I played with several years ago with the infrared sensor. That I had two infrared receivers, and then just a vertical divider between the two. So when I basically had an infrared beacon that it was trying to find. As the robot would turn, then you'd see two when it was pointing directly at it, but as it started to turn left or right, you would see just one of them, and you'd know which way to turn.
Yeah, I could see where that would be. I think that's kind of similar to what he's doing, but he doesn't have a separator, but he's accomplishing the same thing with a slight angle.
Yeah, with the separator, you could effectively do the same thing with a narrow beam type of sensor.
Yeah.
Yeah, because I've got like right here is a you can't really see it very well, but there's actually an upside down mounted servo with a time of flight sensor that looks through. Hold on. Don't want to drop this. It actually looks through that space right there. So there's actually a little time of flight that peeks out through there and is on the servo, so it can go about 120 degrees scan. And I've played with that a fair bit, and this kind of is curious to me in the sense that that's kind of the next stage for trying to use this, because it's not fast enough to run while the robot's moving at full speed, but it can actually scan back and forth like that. And having that ability to track something would be pretty cool, because it's the whole thing weighs only a few grams.
Doug, I don't think that's actually. I think what he's doing is somewhat different than what we had described. Can I present here? I got a picture.
Sure. Yeah. Go ahead.
Hang on. Let's see. Present now. My entire screen.
And then you have to click in it.
I know some people say, well, this guy never builds real robots. Guess what?
Can you see anything?
Not yet, Dave. Did you click in?
It's been a few years since
Yeah, there you go.
How about now?
Yeah.
Okay, can you see my mouse?
Yep.
Yes.
Mm-hmm.
Okay, so basically, if I'm understanding Doug's question correctly, the way the SRO4 robot, for example, finds soda cans, so you've got these two sonar, and each one of them has a beam spread of about 15 degrees, and they're oriented away from each other 15 degrees. That is, the right one is 7.5 degrees to the right, and the left one is 7.5 degrees to the left. So what that means is that to first approximation, the inner edges of those two overlap. Does that make sense?
Yeah.
That is, they're tilted away from each other in such a way that the beam spreads cause the inner edges to. And so that can serve as an edge detector. That is, that angle there, when you get a detection normally inside, you don't know where it is. You only know it's somewhere along in here. But with an edge detector, you know exactly where it is. It's directly in front of the robot. So you actually have a good XY location for whatever it is you detect by using these two edges as an edge detector. So that's how SRO4 finds the soda cans. It finds the two edges of the soda cans, and it knows how wide they should be.
Mm-hmm. And like I said, on my tabletop robot that I used to run, it wasn't as sophisticated. I'd only had one sonar on it, and it used rotation because I knew the soda cans weren't going to move. So in that case, I said, I don't know where the soda can is. So I start turning, and then I'd pick up where the soda can affected the ultrasonic reading. And then I would see it as I continued to turn where it stopped affecting the reading. Then I would divide that number by 2 and I'd be pointed at the can. And that works. It's a little slow, but it works, you know.
This was not that complicated. This just basically sweeps the can and finds the edges.
Yeah.
And those edges, in point of fact, steer the robot into the can. So I'm not actually calculating that part.
David, I guess this is maybe preempts your discussion. Is it this weekend?
Next weekend.
Next weekend. The weekend from this weekend. Okay. But when you say you're getting this edge detection, I'm assuming you're not just taking the distance measurements straight off the sonar. As you're doing some little bit of magic in there?
No, you take the distance measurement straight off the sonar.
Yeah.
But you know, if the object is in that coincident area in the center, you know that it's exactly straight ahead of the robot. It's along those two coincident lines.
So if you got
Coincident
0.9 meters from both sensors, you'd assume that it's getting the same object. Is that what you mean?
You can find that it's doing the same object by scanning it across it.
Ah, okay. It's as those things move, you mean?
Yeah. I've got a video somewhere of maybe I can find it. I'd like to try to present a video. Would you guys mind?
No, not at all.
Let me see if I can find it.
Well, while he's looking for it, this was a little robot kit that I bought and put a Raspberry Pi underneath. This is several years old. That divider that I was talking about, I have these little PIC-based infrared transmitters that I was put around the room. My idea was to try to triangulate based on their location, and the robot could tell where it was. And you can see right up, let's see if I can get this up here. You can see that divider that I've got with the 2 sensors on either side. That was the idea. Turn a little bit, it blocks one sensor, and when it sees a beacon, you could tell if it was pointing directly at it, it would get a reading off of both sensors off that beacon. Anyway, if you got your video, while you were
I think I've got it. So let me see how I do this.
So Murray, I think that would answer your question. Yeah, I guess you could do it. Did you notice how his center divider stuck way in front of it though?
Right. But that would mean I'd probably need 2 of those time of flight sensors.
Yeah.
Do you guys see a video?
Yes.
Yep.
Yes.
Yeah. Okay, I'll try to narrate it as it happens. This SR04 has just put down a can, and it's going to square up on the wall so it kind of can correct its odometry. And then it starts the scan. And right there, that edge crossed the 2 edges of the can, so it knows where the can is. And you can see it wiggling slightly as it scans back and forth those edges so that the location of the can gets better and better as it drives toward it. So then it grabs the can and just uses odometry to bring it back to the starting point.
David, you're always amazing when you take like the absolute simplest approach to something and do the most complicated wizardry thing with it.
Well, I think I'm going to say thank you.
Well, I'm not sure if I even expressed that properly, but it's sort of like you take a rubber band and a paper clip and you go to the moon. I mean, it's sort of like.
Well, you see here that it actually has an advantage because before it actually just started driving, it actually scanned the space to see if there was anything interesting to go toward. And if there is, it just stopped the scan at that point and starts driving. It's more obvious in the second case because I don't think it can find the can until it's close to it. Yep. Knock those cans down. There we go. Okay, so here it did the scan and it didn't find anything. Among other things, it made a note that next time it's down here, don't bother to do a scan because there are no cans. And so here it's just kind of scanning the space in front of it, and bam, it saw that can, which it didn't see when it did its. There's steam for rainwater. with his camera.
So are you David, are you keeping a map at all of the territory?
No.
Okay. This is straight behavior-based robotics.
Basically, when there is something in the gripper, the only allowed target of navigation is the recycle area. So as long as it's holding a can, it has to drive back there. Once it puts the can down, it knows that it's arrived at a waypoint, so it does its waypoint behavior. If you look here, it'll rotate over and square up with the wall, kind of to help with the odometry. But it won't bother scanning for a can because it knows that the last time it was at this waypoint, there were no cans. And okay, so here we are at the other end, and it finally found the last can. There were some rules at one point that said you had to go into all three areas. But they changed the rules. Every time I get the software set up, they change the rules. I'm starting to feel paranoid. Well, I think that kind of describes it well enough. I'll go ahead and stop presenting here.
Well, thank you. That's pretty cool. It just issues me another challenge for me, right?
So I think everybody else that finds cans finds them with their cameras. That's one of the reasons I can find any kind of Coke can. But the contest specifies orange Coke cans, international orange, solid color. You know, those kind you see in the grocery store all the time.
Yeah.
Yeah, well, you got to remember, like I mentioned, you know, on the tabletop, we didn't use the cameras. And
How did you do it on the tabletop?
One ultrasonic. I would drive to, well, I'd be in the starting position. And in my case, I wanted to get out of the black box. You know, there's a black box, which if you drove over it, your drop sensors would say, you've just dropped off the table. So it would move backwards. So the drop sensor wouldn't actually come into play until you crossed over the black line. Then it would come into play. All right. And at that point, then I would just start rotating. Okay. And when, like I say, with a single ultrasonic, you pick up when you see the can. When you went over the other side, you saw where it wasn't, and you just go halfway and pick it up. So, you know, I've done it with both. Now, the guy that did it the slickest was a gentleman who visited us from
Vancouver.
Vancouver. And he used the sharp sensor that was like 90 degrees, and he would run a little rectangle, I believe. And when his sensor passed by the can, then he would rotate 90 degrees and pick it up. I know I'm not doing his algorithm justice, but the video is out there on the site.
I remember that as you described it.
Yeah. So, I mean, that was.
So, Mary, have you got your robot real tree yet that you were going to do for the Mars? I think it was you, right? Or who? Am I thinking somebody with?
Murray's muted.
Oh, sorry. Yeah, I'm stymied in my ability to even browse for parts. So
Well, let me show you something as we speak then. Share. Now lose the share button.
Basically, I think I'll just very briefly describe it. It's basically three robots, three two-wheeled motor controllers, three battery sets, and three controllers, all with a master controller.
Right.
The design.
I found this tonight. So there's a reel with depth. I think we're talking about reels with depth, right?
These are 3D printed wheels?
Yep.
Oh.
I know, minor details.
Yeah, I know. I got to join the cult, right?
But it does have depth there, you'll notice, and it uses a servo, no less, less light in there.
Yeah, yeah.
Let's see. Yeah, there's a better picture of the reel itself. So yeah, you might glance at that. What else? else do they have here?
158, 33.99.
Ooh, they actually have it going up. Okay, we'll run the video. So yeah.
Just a pair of rocker bogies. Oh, and they steer too. Wow. That's pretty cool.
That's cool. That's very cool.
Yeah, I like that. That's a lot less complicated than the six-wheelers.
Oh yeah, that's why I'm thinking, that looks nice.
Yeah, yeah.
Well, Murray, it seems like that with all of the pressure that you're put under in order to get into 3D printing, that puts you in the perfect position to turn that question on its head.
Resistance
Say,
is futile.
well, that's really great. Would you print that for me?
Resistance is futile, Murray.
No, actually, I would say, hey, Murray, look, you could mill those out of aluminum.
Well, you could.
Oh yeah.
Or Delrin. Delrin.
Or you could do what I did this last weekend. Okay, I need to show you something else. So,
well, as much as anything, I like this because even if I didn't mill them out of aluminum or something like that, just having a design that I can see there with the design that I could emulate, that
right.
I still think I'll probably end up with a six-wheeler, but that's pretty impressive.
John, can you put that link in the chat?
Yeah, I'll copy that.
Yeah.
You know, Murray, you could take this idea though, and I think you've already mentioned, but just use a piece of tubing.
Yeah.
You know, to be your depth, and then just put a cover on the end.
Yeah, I mean,
just plastic welded or glue it or whatever.
All the parts that I need, I can probably get from GoBuilda or somewhere like that. It's mostly just the actual steering mechanism, the part, that U bracket that holds the motor and then the wheel. That's the only part of it I can't really build from existing parts.
Okay. And then the other thing I want to show how I had it, since I found the thing. So, and this is for actually for Doug. Can I show you earlier the one I had built? What did I click on the right thing? Okay,
yeah. Sure.
So I think you're seeing this.
Yeah, we got
okay,
mini
good,
rover.
because I'm like seeing two. So yes, this was the original design I built mine off of. So that was that. The only thing was I built the real battery holder in the middle there to bump up, but this was the original one. You can see where, the real servo basically fits in there. And the reason I like it was it had the clog. It was going to be for, the Syscan type thing. So that was, I was thinking tabletop originally was when this one was, but I forget which one. But yeah, there's that too. So, and if you don't have a 3D printer, okay, I'll show you one little thing that I did do this last weekend while we had all the rain. These hopefully it'll work. This will work. So this is why I cast with mills. So you can 3D print and then cast at mill. Okay. So and I thought it was cute. So yes. So no, I really didn't work on a robot per se.
Murray, just use a chisel, get some material.
Hey, I just had over the weekend my basement flood once again, so I've got another layer of mud down there. So my cache is now going to be house repairs for a little while, not robots.
Sad to hear that.
So,
and I live on a hill. You would think this didn't happen.
Yeah.
Now, one thing I wanted to say back on my experimentation with infrared, I want to point out is don't assume that if something's transparent to visible light, that it's transparent to infrared. I found that out several times. Like I think I printed that little divider with ABS plastic, and I couldn't get it to work right. And I found out, infrared goes through ABS plastic, even the black ABS plastic. So I covered that in like carbon black ink. I had to paint over it in order to get it to block the infrared. The other experiment I did recently with my security camera is I needed to put a window over the camera to keep the moisture out. And I took a piece of acetate film, like you put on a overhead projector transparency, that scatters infrared light. Looks perfectly clear and visible, but when you try to look through it in infrared, it's all fuzzy because it scatters infrared. So finally found out plexiglass works fine. Lexan or plexiglass or whatever you want to call it.
Well, the only problem though is you get lots of, like I on my front bumper on my robot is effectively, well, it's polycarbonate actually, but the problem I found is that there's so much reflection off the back of it that you end up having all sorts of issues.
Well, also, if you're using Lexan polycarbonate, compared to plexiglass, it has a high index of refraction. That is to say, it really bends the light as it goes through, and that can affect the pathway of your optical sensors that are mounted behind it. And you can see it. I mean, if you hold it up, you can see it's like a little magnifier.
Yeah, I found, well, it seemed like it was clear until you put a sensor on the other side of it.
And you know why it is some of those photons travel through and some of them get reflected off is one of the deepest questions in modern physics. That's absolutely true.
It's something to do with spin, right?
It's a hugely complex. There are multiple PhD dissertations. It's a hugely complex area. Why some of those photons choose to pass through and others choose to reflect off the front surface and others choose to reflect off the back surface is a deep, deep problem. And if we knew that, the answer was probably 42.
Yeah.
And who knew that photons had free will, right?
That's what it looks like.
Yeah.
Well, actually, to try to solve the problem of what materials to use several years ago when I was playing with this infrared beacon, is I actually started looking on websites to find the transmissivity of different materials to different wavelengths. Before I basically committed myself to any part of the design of using a particular material. Takes a little bit of finding information sometimes, but you can find it.
Mm-hmm. If you were doing it again, what would you have used?
What, you mean in terms of materials?
Yeah.
Oh, I don't know. I just, believe it or not, oh boy, I've got to show you this too. See if I still have it. Oh yeah. This is back in the primitive days. You're going to love this. This is my version of a scanner. All right. It's 2 plastic pill bottles. I've got a vertical slit here that the infrared can pass through, the infrared from the beacon. And then inside, there's a smaller pill bottle that's facing down and it's sliced. It's got a diagonal, basically it's cut diagonally. So when this servo on the top turns and the bottle inside turns, this gap opens and closes. All right. So basically it was telling me how high on the wall the beacon was mounted. All right. By the position of the servo, the assembly inside. And then, of course, the bottom would sit here and rotate back and forth to sweep around the room until it found a beacon on the wall. I mean, and then I've got my infrared receiver on the back right here. I mean, this is about as, duct tape and whatever you want to put together. This is about as primitive as it gets. But that's basically, it started this many years ago, so. But I kept it as a sort of memento,
Mm-hmm.
But yeah, I had to paint the pill bottle with carbon black ink because this one was giving me fits. I think this is where I found the problem with this type of plastic, and then the 3D printed plastic, I found the same problem. So I don't know what this plastic is made of. I didn't bother to look it up. I have no idea. Unless it's got a recycled symbol on there somewhere, I wouldn't know what the plastic of the pill bottle was made of.
If it's a normal pill bottle, I think it's just polystyrene is my guess.
Yeah, probably so.
You can look at that through cross polarized filters if you have some handy. 2 pairs of polarized sunglasses will do it.
What do you mean?
Well, different plastics bend the light a different amount as they go through. And if you look at it through polarized filters, you can actually see the light. It'll be different colors.
Oh, okay. I was curious because I was using infrared. I didn't know.
I'm just talking. Oh, yeah, that's a good point. That's a good point. I don't know. I was just talking
that's
about.
why I was so confused.
No, I just meant visible light.
I'll just tune my glasses for infrared. So.
I know in the infrared sensors that I've used over the years, one of the problems is keeping the infrared from leaking out into places that you don't want it. And what I've found that works for me is cardboard spray painted flat black.
Yeah, because a lot of those paints actually have carbon in the black colors too.
I've had pretty good luck with black with heat shrink, black heat shrink.
Yeah.
And I'm not. The one thing you have to be careful about is the LEDs actually emit light in all directions. They have a lens that they tune the front, but it comes out the sides enough to screw up the next sensor if you've got a row of them. And they'll even come out the back, but usually you're not worried too much about the back because it's up against the PC or something, PC board. But I've used, if I wanted to cut the cone down, I've used a black heat shrink.
Well, I've seen that work, and I've seen. Oops, am I presenting?
No.
How about? It shouldn't require so many button presses. There should just be one button press.
Just think present, and it should happen.
I say, present. Do you want me to allow it? Can you see anything there?
Some politician who accidentally presented some parts of his body.
Yeah, or the one who was a cat. I am not.
That was funny.
In front of the judge, yeah.
Can you all see this? Is that up?
Yeah.
Okay, this is looking at the bottom of the RCAT robot, and there's 2 IR sensors, one here and one here, and they have a IR LEDs on either side, but here in the middle, I've constructed little cardboard painted flat black, basically shadow boxes. So on these sensors, the detector is here on the middle of the board, and there's a IR LED on each end. I don't know if you can see that. There's one here and one here. And so this little box keeps the sensor from seeing the IR. This is what Doug was talking about. You could also put a piece of heat shrink over that. But in this case, one of the problems is I get these reflections off of the bumper. So this box is actually connected to the bumper, and so that light can't leak around in between. But every IR implementation I've ever done, I have to do some kind of shadowing like that. These 2 pieces of black tape on the front bumper also prevent the IR from seeing the floor. So that's kind of a, what do they call those? Like a Leco light, like a, for those of you in the theater world.
First rule of theater, right? I was going to ask David, do you think that on these normal sharp sensors, the 1.5 meter ones, do you think that you need to have a shadow box on those if you've got 5 of them on the front of your robot?
I don't think so. They're real well designed to not interfere.
Okay, good to hear.
That's a good question, though. You know, normally the way infrared is handled is that there's a 40 kilohertz modulation. So you're not just looking for infrared, you're looking to basically phase lock onto a 40 kilohertz signal. So the question I guess you're asking is, can one sensor log onto another sensor's signal? And I guess I don't know the answer to that.
Yeah, and I don't. And the fact of the matter is that right now, I think I've talked about my integrated front sensor, which has got 5 of these things, and the ones on the sides aren't the problem. It's the 3 in the center that overlap a fair bit, and with reflections, they could easily be seeing each other's images. And when I send out a request to this front sensor, by the time all 5 and the 3 bumpers have come back, that's like 180 milliseconds. It's a lot of time for all those sensors to gather data and send it back over what was I2C, but it's basically a serial interface. And so now taking those 5 sensors and cutting them off into, let's say, let's go now you go, now you go, now you go. By the time that came back, it would be several seconds later. I mean, it just takes too long.
Well, Murray, on your bumper, which is your sensor of last resort, you know, that thing should be continuously polling.
Well,
you know, you should. I mean, I understand the idea of the I2C, but somehow they have to have priority.
Well, the way I don't disagree, Doug, and the way that I've designed this thing is that the whole assembly can come off the front of the robot and attach to the robot, actually to either one of 2 robots, and the only connections between that front assembly and the robot is it's 5 wires, and so actually 4 wires, and so it's one of those things where, yes, I probably should break off the 3 wires for the bumpers as separate GPIO signals or go into interrupts or something like that.
Yeah.
Because the bumpers, yeah, they would take too long. On the IRs, if they're a bit slow, it's not a big deal, but on the bumpers, it should be pretty much instantaneous response.
I think I'd probably go with Doug there, Murray. If you look at something like one of those Sharp IR rangers, I think you can only I think they run at best at something like 40 hertz or less. On your actual physical bumpers, the bumpers on my robot, I poll those, and I poll them at 100 hertz, even though the robot response time is down at 25 hertz.
Right.
Because those things can happen real quick, and you don't want to miss any of them. Whereas with the IR, it doesn't matter; they're not going to be ready. You know, from the IR, you're only going to get 20 or 30 samples per second anyway. So it doesn't really make any sense to try to sample them that higher. So when you mix together those high bandwidth and low bandwidth signals, then you'd need everything to run at high bandwidth in order to get the high bandwidth signals through. And that sounds like what you're describing. Am I totally misunderstanding here?
No, and I don't, like I said, pulling the 3 bumper switch signals off and running them through interrupts or running them as a higher priority is certainly not a bad idea. The way that I've kind of gotten around it, at least theoretically, I haven't actually tested this yet. It's one of the things that I'm hoping to do when I finally get this message bus working, is that between the publishers of events and the actual controller is an arbitrator, and the arbitrator is basically a message queue, a prioritized message queue. And so the bumpers are a much higher priority than anything coming off of, let's say, the IR. So what will happen is that the messages coming off the bumpers will naturally filter to the top of the arbitrator and will be the first thing that gets pulled off the arbitrator to the controller, and therefore will be the first thing that the robot does on a 20 hertz loop. But polling at a higher speed isn't a bad idea. And I think we've talked even about, well, while Chris was here, we've talked about implementing a real-time operating system on the Pi, but I really don't want to do that if I can afford not to. I mean, it's just a lot extra trouble.
I'll give you one. Murray, you know, if you'd switch to a C and to a STM Nucleo, I'd give you all my code.
Yeah, but I wouldn't learn anything. Well, that's not true. But no, frankly, I still have in the back of my mind, I like working on SSH on a Pi and all that I've talked about. Once I've got this Python assumption architecture kind of functional in CPython, I'd like to try to port it over to MicroPython, because I've got I've got a Feather S2 and a couple of these unexpected maker tiny Picos, and these are like 200 megahertz ESP32s. And unfortunately, the I2C slave functionality hasn't been implemented on these, so I couldn't use these as subcontrollers or whatever you want to call the subprocessors on the Pi. But of course, as you would suggest, I could use these as the controller for the whole robot. And they're certainly fast enough. I don't see the reason why, if anybody can run a robot on an Arduino at 16 megahertz, why these at, I think, 120 or 200 or whatever would be plenty fast enough if I'm not doing anything else. I wouldn't have any Wi-Fi or anything like that. I give up all those luxuries to have a functional robot. So
I would just mention, in addition to that, and maybe I should bring up I don't need to do that. Just bring up in your head the previous picture I was showing. Those sensors are in pairs. If you look at my robots, always the sensors are in pairs. There's a left and a right sensor. And those sensors in particular have a left and a right LED. So you can have, basically, you can turn on either LED and then turn on the sensor and see if you get a return. So what that means is you can turn off the LEDs and just see if there's any IR beacon out there you might want to try to navigate toward. And because you have two sensors, you can do that. That is, you have a left and a right sensor, so you can steer, use that to steer toward a beacon. When you have a center sensor, and Murray and I have talked about this before, it's more problematic to know exactly what to do. The simplest case to think about that is just think about a bumper. You know, if you hit the bumper on the left, well, you obviously need to turn right. If you hit it on the right, you obviously need to turn left. What happens when you hit it in the middle? Well, it's not so obvious what to do, and that invites some creativity. So in general, like if you look at my bumper, it's designed so that it's real hard to hit it in the center. If you hit it even a quarter inch to the right, you'll get a right detect, because center detects are not that useful.
Yeah, and frankly, on the infrared, I have 3 infrareds: the center, 2 obliques, and then the side ones. And the idea I've had, and I've actually have programmed this on the KR01, is that the center bumper, of course, yes, it is an obstacle detector, but the 2 oblique ones are the ones sort of like you use, David. But the central one is used for a different behavior, actually, and that's to slow the robot down as it comes up. It's got a single behavior that, as the robot, I've even demoed this in a YouTube video, that as the robot comes up to a wall, it will go from top speed and gradually go down. It slows down until it gets to a certain distance from the wall and literally stops. So you can actually see as it drives up to the wall, it just gets to that, I think it was like 30 centimeters. I can't remember what I had set it for, but it goes from top speed, and then that, if that center starts to get any kind of signal, it basically sets a limit on the motor speed until it gets to a certain distance, and then it says stop. You can't go any further. And that was just a single behavior.
Does it actually scale the speed by the distance to the wall?
Yeah, exactly.
That's the way to do it.
Yeah, it's pretty cool. When I first had it running, it was like, oh, it actually worked. You know, it's like
give yourself a gold star.
Yeah. I actually have one of my YouTube videos that actually shows it. It drives up towards that pink and white wall and just goes and comes to a stop. And then once it had done that, it went into a vehicle or avoidance mode, backed up, turned, and then scanned along the wall until it saw the wall fall away, and then turned towards the hole. And that was the only behaviors I'd programmed at that point. But it was nice to actually see it do something like that.
When I was doing the Robo Columbus development, I was trying to use the sonar to measure the distance to the cone in exactly the same way, so I could decelerate as I approached the cone. But what I found out was that it's pretty hard to get a sonar reflection off a cone. It's possible. I actually, I have to reorient the sonar in order to do it. I've got it on a little servo, so I can adjust it. But it turned out to be easier that the camera that has spotted the cone, as you drive toward the cone, the camera tries to keep the cone in the center of the field of view, which means that as you get closer and closer to the cone, the camera's got to pan down. It's up on the mast. So when you are really close to the cone, it's really pointed down at a steep angle. So what I ended up doing is the angle of the camera controls the speed of the robot.
Right. Oh, okay.
So that as it gets closer and closer, as that angle is tipping down to maintain the cone in the center, that slows it down and brings it right into the. Actually,
so it's not the symptom; it's actually the cause.
Yeah, I actually read back from the servo angle, and use that to control the speed.
This is my Ernst Blofeld cat. I'm going to take over the world. Exactly.
Complete with soundtrack.
He must be hungry. He's starting to bother me.
Oh, I was on mute. I was saying Murray is not a cat.
Yeah.
You made me look around because I thought that was mine.
His name is Akio. He's a Japanese cat. Anyway, thank you, David. I always learn something.
That always makes me nervous.
Sorry to make you nervous. It's not my intention.
Gentlemen, I think I'm done for the evening.
Yep. Likewise.
Not here. I have a thing for Doug though, and is anyone online interested in a brief rules discussion for the August contest? No. Okay. Just a quick thing for Doug, because Donna had. Okay. So there was some email traffic back and forth. Donna posed a question.
Oh, yeah.
And I posed some feedback, kind of to limit it. I think just Donna and Doug, or maybe someone else. Can we go with the thing I wrote, or is that a bigger discussion? And this was on the permissions question.
Yeah. I think I agree. I think with the concept, and I might. The wording might be might want to change a word or two, but I'll be quite honest. I just haven't had time recently to revise the rule or revise the guideline, and essentially what we wanted to do, so everybody doesn't wonder like, what secrets do they have? If you read the guidelines, we said that the person in a remote location had to get permission to use the material, and that they also had to send the site location to us so that we could make sure that it was suitable to run the contest. But what we didn't want to imply, what we were trying to imply was the contestants responsible for determining what they need to use the site, because we don't have anything about the use of the site. Well, anything that DPRG is going to do is simply say, well, if you were using that site, yes, you could run the contest. Okay, then I think that's what everybody from all the discussion. Carl, you agree?
Yeah, I think so. I mean, if we're not concerned about liability, we say it's up to them.
Well, it's
I
the
just want to respond to
liability. They
Donna.
attach liability themselves. It's not our responsibility.
Right.
Yeah, because I don't think it happened this year, but sooner or later, if you were to allow just remote people to come in, and somebody would say, well, I was only doing what DPRG said I could do.
Right.
And then we would be,
I think it's a good point, but if we can agree to tweak the wording, I just want to get a response to Donna and say, yeah, in principle, what I wrote is what we're going to do. The exact details, we're going to fold it in sooner or later.
Yeah.
And we don't, and the other question, if we're good with that, then that's a good thumbs up.
I think that's a good thumbs up.
Okay, so I'll give
Yeah.
her a response. And then the other
Yeah.
thing is, she's asking if we're going to have any more rules changes. And at this point, I think
As long as she doesn't bring them up, I would say no.
I
But
thought we were done.
that's
Okay.
what I was thinking.
I
Sort
actually
of,
was pretty happy with that guideline. So
I'll respond with her that way then. And
yeah, and no, the intent is there won't be any rules change now.
but I can see adding the a little bit about no, we're not picking the site. It's up to you to get permission. Blah blah blah.
Yeah.
Type thing. That part I do agree. I can see adding that, but
I mean, I think if you read the current statement, I don't think you would misinterpret it. But I do think.
Clarification is always better. I can
but
save people.
Donna did, Doug. Donna found it unclear. So
yeah, that's what I'm saying. That's
yeah. So if somebody can find it unclear, we should clarify it. So let's work on the wording. But in principle, I think we're on the same page.
Yeah.
And rather than hold everybody on for a rules discussion.
Yeah.
Well, yes. If Murray and
We
then want to
can-
get off.
Yeah.
So.
No, I think that's fine.
Yeah.
And
I
then
hope
Carl
you turned it off, didn't you? We're not
He'll
recording.
edit. He'll edit.
No, I will stop it now. Okay, this is the end of the recording. Good night, everyone on the recording.